Okay, well, good afternoon, everyone. And on behalf of the Foundation Institute and the European Federation of Foundation Contractors, I'd like to extend a very warm welcome to you all to our conference on deep foundations and ground improvement, with a particular focus on smart construction for the future here in Berlin. And what better way to address the smart construction for the future by having a digitalization workshop. So thank you very much indeed for coming along to today's session. And from a personal perspective, I'm Jason Boddy from the engineering consultants Arup. I also chair the Deep Foundation Institute Digitalisation Working Group here in Europe, and I'm particularly delighted to be here in person. We've all been working virtually for the last few years, the last couple of years, so to see people in the flesh is a real pleasure, and it's great to bring us all here together in Berlin. I'm also very happy to sort of extend a very warm welcome to our guests who are joining us online as well. This presentation is also being shared via Zoom to the DFI members and EFFC members. So in terms of the programme for this afternoon's session, I'll be beginning with just a few words of introduction, and then really what we wanted to address in today's session was one of the challenges that we face in digitalisation, and that's really looking at how we share best practice, how we collaborate with one another. So really the theme of this afternoon's session is bringing together different views from Europe and across the wider globe on where we are in terms of digitalisation and how we can better collaborate with one another. We'll begin with a presentation from Matthias Cravare from Paul Annalus, and that will look at a Swedish perspective on digitalisation and visualisation from a foundation contractor's viewpoint. We'll then be moving over to Germany, and Sebastian Kaluza from Arbaut GmbH will be presenting on how he's broken down silos to help data analytics to see the bigger picture from a specialist foundation contractor's working site. Mark Pennington from the UK will then be giving us his viewpoint. Mark's from Balfour Beatty Ground Engineering, and he'll be sharing how we need to get the right mindset for data management to help digitalisation. We then got a half-hour break. We'll then sort of move on to hear from Diederik Bouwmeester from Fugro in the Netherlands, and Diederik will be telling us about digital transformation and how they've used machine learning and ground modelling to help really move ground investigation information into the BIM space. And then we'll be wrapping up with Jamie Rosen. Jamie chairs the DFI Project Information Management Systems Working Group, and Jamie will be giving us a perspective from North America, and also sharing some of the work that the DFI have been doing, looking at specifications for ground engineering data management, and Jamie works with Geotechnical consultants across North America. After those presentations, we'll then have an open panel discussion. So we'll be inviting all the panel members to come and join us at the front. We'd really like to sort of get your views on the questions that you would like to ask our industry specialists. So if you do have any questions as the presentations are going, if it's specific to the presentation you've heard, then we'll have plenty of time in the programme to ask each specific presenter questions. But if you think your question's a little bit more general, then it would be a good question to ask the whole panel. If you could hold on to it to the end, that would be very helpful. And hopefully, technology permitting, we'll also like to just do a very brief online survey at the end of the workshop, just to get your views in terms of where you see digitalisation in ground engineering at the moment. So just to begin, I really wanted to start with just a brief definition as to what we see digitalisation to actually mean. And that's sort of creating and using digital geotechnical data and project information to make better use of digital technologies throughout design, construction, and operation of a particular project or an asset. And I'd like to focus just specifically on creating. So digital data doesn't just automatically exist. It's our responsibility as ground engineering professionals to make sure we're specifying that digital data is captured on our projects, that we're using appropriate technologies, sensors, digitally enabled equipment to create digital data during the construction process. And then that we're also using appropriate apps to gather that on site and embracing that digital approach. So the creation of that data in the first instance is something that we really need to be very careful of. And then finally, just again to focus on, digital data isn't just something that is created on site when something is being built. Digital data should exist throughout the entire project life cycle. That's when we'll see the entire benefit of digital data and digitalization. If we bring that concept into the project right at its concept, it then informs the design process, and that information, as it changes and develops as the project progresses, is then passed on and shared from each project participant. That can then be used in the operation and the maintenance phase to make sure that maintenance is done in an effective and efficient way. So if we consider that project life cycle, then it's very important that we think at the outset about how we create that improved high quality data and project information that will then provide those future benefits, not just for that particular project, but for future projects as well. Once we've created that data, that enables much better collaboration and coordination between different parties if that data is shared in an open and collaborative and a standard way. I'm sure you're all familiar with the benefits that we get from the avoidance of human error by using digital data, and the potential for crash detection, for example, when we're working in a BIM space. But then we can also see that when we have sort of more efficient project delivery from using digital data, it brings real benefits, not just to the construction process, but then also to the whole life cycle of that particular project and asset. So there are clearly many different opportunities for cost saving and risk reduction from digitalization, but it can also lead to improved safety on our construction sites, can lead to automation of our design and site recording processes, and it can also help with sort of predictive modeling going forward. So that ethos of sharing data, doing that in a standard way, is fundamental to the success of digitalization. I'm pleased to say that those principles were embedded within sort of the European Union's digital strategy, which was issued in 2020, and then the Data Act, which came into force in the European Union a couple of months ago, has at its core the recognition that digital data is highly valuable, that it should be shared, and it promotes the sharing of that non-personal data in a very open and transparent way, and that we should also be using sort of standard data formats so that data isn't used or produced in a way that only the manufacturer of a particular piece of equipment or an instrument can use it, but it's done in a way that others can benefit from that data as well. And so when we get to that point that we're sharing data in an openly collaborative way, in a standard data format, it really does open up huge opportunities. And in fact, potentially you have the world at your fingertips. And the EU's digital strategy has one project. I thought I'd just include that here, which is the Destination Earth project. And that's the aspiration to create a digital twin of the Earth itself. That will help with the modelling of climate change, predicting extreme weather events, and also test the effectiveness of adaptation measures. And in order to do that, they'll be creating a huge data lake. And now it's not intended to just create a model for predicting climate effects or predicting weather. This is really looking at all sources of data. So user data, the Internet of Things, environmental, economic and social data, to see how all of the global infrastructure interacts with itself. And I think there's a very important message there that digitalization can be very much at the heart of our drive towards a more sustainable future. And also that's the session that's running parallel next door. So it's great to see that there's excellent linkage between digital initiatives and sustainability. It's also interesting to note that digitalization is big business. In the first 3 years of this particular project, the European Union are investing 200 million euros just to set up the groundwork for the data platform, the data lake, and then starting some of their initial modeling exercise. So significant investments are going into digitalization in that particular space. But digitalization isn't without its challenges. The DFI organised and hosted a digital panel session in the UK last year at the British Geotechnical Association's filing conference. And again, we posed a series of questions to industry leaders. And it was really interesting to see that a number of the key challenges were all associated with data. whether that's the legal issues around sort of data in terms of its ownership or liabilities that you attract by sharing data, the issues associated with data formats and the fact that clients aren't specifying data collation was one of the issues that was identified. And then also when data is received, if it's done in a non-open or a non-collaborative way, it can be very difficult to check and verify that data. But it wasn't all doom and gloom. We didn't just ask for the problems. We did also explore what do we need to do as an industry to try and solve some of those issues. And again, the three sort of key aspects that came up were making sure we have more industry events to help share best practice. And that was really the driving philosophy behind today's event, bringing together diverse views from across Europe and the wider globe to get people's experience of best practice and how we can share that amongst one another. Another key challenge was the requirements of the standardization of specifications around data sharing and how we look at more common data formats. So in one of our presentations today, Jamie will be sharing his thoughts on the work that DFI have been doing globally on the standard data specifications. And also in the UK, we've been working on an initiative around standard data formats. The DFI have been collaborating with the Federation of Piling Specialists and the Association of Geotechnical and Geoenvironmental Specialists to look at how we can create a standard data format for pile construction and design data. So that format's now it's now out as a draft for comment within the industry, within the UK. Through the DFI, we're also collaborating with other European countries, looking at similar initiatives. There's a similar initiative in Germany at the moment as well, looking at the capture of pile construction data. So again, a great example of how working collaboratively, we can start looking at bringing a bit more standardization to our data capture to really help with that collaboration going forwards. So they're just some of the activities that we're undertaking, and we're always keen to get your views as well. So again, hopefully in today's session, we'll get some lively discussion, get your thoughts on areas that are challenging us within digitalisation and what we should be doing going forwards. We're always keen to get your thoughts. We're always keen for offers of support. So again, if you'd like to find out a little bit more, do please contact me, and I'll be very happy to hear from you. So thank you very much. We'll now move on to the main presentations. So over to you if you're happy to.
Yeah. There's a question. I don't know if you
okay, yeah. Thank you, Kieran. Yeah, so again, anyone who's joined us online, if you just pop your questions in the chat, please, and we'll pick those up.
It hasn't. Now we just need to get back to the Zoom.
Okay, well, allow me to just introduce our first speaker now. So I'm delighted to be welcoming Mattias Gravare from Paul Analus from Sweden. Mattias holds an academic degree in both construction engineering as well as IT and systems analysis. He has a genuine interest in new technology in general and in IT in particular. He's the owner of Paul Analus, a pile testing company with its base in Gothenburg in Sweden. Apart from pile testing and pile analysis, he's also the founder of the IT system ProPile, which is a digital platform for a piling contractor to manage and visualize data produced on piling projects. So Mattias, over to you. Thank you very much. Okay. Shall I? No, I think I'm talking enough, so I think I should be okay.
Okay, thank you very much for letting me talk here, and thank you, Kieran, for inviting me. I'm honored to be here. Yes, as Jason said, my name is Mattias Gravare, and I'm the owner and CEO of Paul Analus AB in Sweden. We're doing pile testing is our main business, dynamic testing, but we're also developing a software for the foundation contractors in Scandinavia. So this is what I'm going to show you today. So my presentation, I'm going to talk why I'm here. I will talk a little bit of the Swedish way of piling, because that will sort of get you to understand the features that we built into the system. I will show you the profile system, of course. And then finally, I will get into the key features in the system that has been proven successful. And I will also sort of address the key software development strategies that we have adopted to get through with the software and to make it successful. So Paul Analysis is a testing consulting company. So we're doing dynamic pile testing, and we've done that since the 1970s. We've always been found in IT and new technologies. So in the late 1990s, I think we were the first in the world to conduct dynamic testing over the internet, remote testing. And remote testing is today what we do all the time in Sweden. And we're working very closely to the Scandinavian piling contractors. They have to verify that their piles are okay and withstand the load that they are supposed to do. So they hire us to do the testing. So we talk closely to the Scandinavian piling contractors. And that led to that we understand the situation of our customers and what they want. And since we like new technology, we sort of started, thinking about how to digitalize what they're doing. So we started off by digitalizing the daily piling report. So the system focused on digitalizing the production process and not, the big view, not the design or anything, it's the production process. So ProPile is the system, it's the sort of a Swedish example. It's an online and real-time software, which is important, and many softwares are nowadays, but it's still very important to be online and real-time. And we sell it as a software as a service. All the data is accessible through standard web browser, iPads, cell phones, and so forth. There's no sort of third-party software that is required. Various stakeholders can access and enter data into the system, such as rig operators, surveyors, clients, etc. We use barcode scanners in the system for increased data traceability and accuracy. And we have an in-house development of a visualization tool that we developed in-house for visualize the foundation in 2D and in 3D. So the Swedish way of piling, well, the geology in general terms, it's very soft soils overlaying very hard rock. And the majority of the piles are driven precast piles, segmental piles, or steel piles. That sort of the majority of piles. The piling contractor usually gets information from the client of suggested length, pile length, but they have to sort of add a little bit extra to be able to get the pile to the bearing, to the good layers, to the hard rock, so they have to add a little bit extra meters so they don't get it below the cutoff level. They get paid to the cutoff level, so there are some incentives to optimize the pile lengths. And of course, it's not always good correlation between the site investigation and the outcome of the piling works, which is not probably only in Scandinavia or in Sweden that it is that way, but still. So this is the ProPile system, which sort of is like a cloud-based system. So you have the database in the center, and to the right, you have the iPad, cell phones, and scanners that resides on site. And then you have the ProPile web app, which is office staff can, print and view and edit everything. You can also retract data out from the database and work in Excel if you so wish. Generally in Sweden, at least when it comes to piling contractors, there's not a format that they get things in. Well, the format that they get things, the data is in PDF, really. So you need to sort of take that PDF file and put it into the Excel spreadsheet and then import it into the database. That's what we do it now, at least. The foundation techniques that we currently support is driven precast concrete piles. It's drilled and driven steel piles and sheet piling. We also have an app called the Profile Viewer, which is for the staff, office staff, project management, to be able to view the projects and see what's going on, you know, follow up on statistics and problems and view the drawing, view the 3D model in the cell phone. So through a standard web browser, you can really update, edit if you wish, you can sort and find data that you need to have a look at. As I said, you can retract the data out and work in Excel, and nowadays it has come to the end that they really work in profile system, but it has been for a while that they sort of retract the data and worked in Excel because they were used to it working in Excel, but it's getting better and better. Of course, you can print the daily piling report into PDFs that they hand over to the client, and you can choose whatever columns you want to show or hide, depending on what's required in that project. We also have pile cost adjustment, so you can add prices into the system of what the pile cost, an additional meter or less meter. So at the end of the day, you can sort of print that and hand that over to the client and request money for additional work. There are statistic featuring, so you can follow up and do prognosis. So you can sort of pick 2 dates and see how many, you know, machine days it was between those 2 dates, and how many piles you've done, how many meters, etc. You can also do prognosis. So you can add like different rigs being on site between which dates they are there, how many days per week they produce, and how many meters per day they produce. And if you do that, you can get like a graph showing, and this is the blue graph showing the prognosis. So you will get up to the red horizontal line, which is the amount of piles in the contract. So you can see when that is reached, and the yellow is the as-built data. That's the production rate, actual production rate. And you can get this in numbers as well. So you can tell how many piles you install, how many meters have been installed, and how many days that are still to do, how many days are left until you're done. One of the features is the barcode scanner. So you can you have a barcode that is sort of connected to the rig, not physically, but through the web. So the scanner is also connected to internet, and you state in that app to what rig you belong, so that rig can see what sort of piles he has in front of him in his stock. So you can scan when the piles are delivered on site as an acceptance inspection, and then they will be sort of in the site stock. And you can scan the pile when it is to be installed, when you lift it up and start hammering. And this, of course, improves the traceability and accuracy of data. So in the protocol online, you can, for each element that builds up the pile, you get that barcode into it as well, so you can see which barcode has come into which pile. There's also a feature where you can see what's on site, the stock on site, so you can see how many of a particular length is on stock and when it was scanned. And there's also traceability features, so you can see if you get an error, or if you get bad concrete or bad steel or whatnot, you can find that barcode and you can see into which piles these segments went. One of the big features that we have is the 2D and 3D model. So if you add coordinates to the piles into the system, you get them on a drawing. So you can view them, and you can do it through a standard web browser. You can do it on your iPad, so the site crew can see it. They can click on it. And green piles are installed and gray piles are not installed. They are to be installed. And the red arrows is pointing, that's inclined piles, so you can see to what direction they are inclined. If you zoom out, you get instant and real-time data visualized. So this is, you don't need to add any other data to it. It comes in, and it's you don't need to worry. It's there for you. And it's accessible, as I said, through standard web browsers. You can filter and find piles by use of coloring. So you can tell which one are broken, which one has been PDA tested, and you can add other criteria that you want to show. We also added those gray squares that you see, and that's in Sweden. We need to do dynamic testing on 3 piles. A minimum of 3 piles in a 25 times 25 meter square. So it's quite easy to see that you have tested enough piles as well. And then, of course, you can go into the 3D models. So you can view it in 3D. And it's quite handy in sort of 2 perspectives at least. But I would say more. But as we've done now is that we may let the computer help the site crew to estimate the pile lengths of the piles. So the green piles are installed and the gray piles are yet to be installed. So you can click on any of those gray piles and the computer will tell how long that pile is, can be. You can also click on a button and get all those lengths out of piles to be installed. So the computer helps you with estimating the pile length. As I said, it's instant visualization of actual data. And this has been proven to be very successful when it comes to, for the contractor to discuss problems and to sort of request additional costs. And this is a real example, and to the left is site investigation. So that's the estimated length that was in the tender, and to the right is the as-built data. So that was quite some different in the length of the piles, and they had problems and things like that, and piles were broken, and they could discuss that quite easily with the customer. This is another real-world example. The yellow piles are PDA tested and the red piles are broken. And the red piles sort of tend to be in a line sort of going across the project. And if we hide the piles, you can see that's sort of a rock wall more or less. And if we turn it around a bit, you can see that it's that sort of wall, or that was something like 5 or 7 meters in depth and almost vertical. So they broke a lot of piles there. But yet again, it was easy to talk to the client and to request more money. And so it's becoming transparent. The work is transparent to the client. So what's coming next? Well, we're working on getting the PDA data into the system as well, so you can sort of add the capacities of the piles. But hey, you can think of anything, blow counts or concrete volumes or installation time, anything that really, make the model better and easier to discuss problems with the customer. So the key features in the system is that it makes data available for everyone involved in real time, and it's all accessible through standard web browsers, iPhones, iPads, and so forth. The system features are currently centered around the requirement and wishes of the piling contractors. So we haven't really, thought about the bigger picture yet. We started off small. The barcode scanner improves the accuracy and traceability of the data that is collected. And the implementation of the online 2D and 3D model has made it easier to understand the foundation and the project, and it's transparent to the client. Finally, want to address sort of the key development strategies that we have. And that is that we have, online in real time. I mean, that's probably most of the softwares are done that way nowadays, but it's still important to emphasize. And what we did was to focus in on actual needs. In our case, it was the site crew and the processes, on site that we focused on, rather than focusing on, the design or anything else. We focused on that. So we had an actual problem that we want to support and digitalize, to help them in their work. And that's what I'm trying to say with the bottom up. We sort of started off with some basic things that we know that they needed, and then we work our way up and we added more features to the system later on, rather than, starting off with the big thing and then never sort of really coming to the target. And that is what I mean with the development based on what the customer wants and not what you think is needed. And that's probably applicable to many industries. But when you're working on data and digitalization, you can quite easily get carried away and maybe thinking too big sometimes and sort of not getting it to work. So I sort of say we started off small and work our way up from there, which was successful for us at least. And also that the real-time visualization of data has proven successful. Thank you.
The traditional data means data find depth, for example. Is that come from the monitoring system? So what, or does the operator just
it's all manually entered now. Yeah, we're working on getting machine data into the system as well, but as of now, it's all manually entered into the system.
Examples where the data has been used to show the changes in ground conditions, and that's what helps the contractors prove the case to a client. I think one of the benefits of your system is that it's a real-time system. I mean, have you had some experience in real time that change in ground investigation information being fed back to the designer, so that the design can then get changed during the construction? Then hopefully get to the point that
we have one now that we're working on it, to do that. I mean, we really don't handle the data that much because it's the contractors and we don't really get into it that much. But we've been doing it now. We have a project where we're doing testing as well and sort of working with Profile to sort of get that into the design and maybe redesign depending on this. So yeah.
Yes, I love that your system exports to XML. Is that to be compliant with any specific open format or document format or anything like that?
No, that's just for, we built that XML sort of structure ourselves. So yeah, and we haven't had any questions. No one has really asked for having it in another way. It's just no. Okay.
Okay.
Thank you. Thank you.
Just one more doing that. Let's go on our next presentation from Sebastian. Sebastian is the founder and CEO of the Digitalisation startup in DFI from Munich. He holds a master's of business administration and engineering and a bachelor in engineering and civil engineering. Sebastian is a former construction manager Construction manager, spent 7 years working on large infrastructure projects in leading construction companies across Europe. He then realised an untapped potential of data and data analytics in the construction industry, the idea to found how about both class and thanks for doing it today. Thank you. Also, it's you guys.
Ideally, so they can see you.
The slides as well.
Just this one. If it doesn't mess with my team, just it's not. I don't
Can I go? Where can I go back? Okay, doc. Yeah. Hi together. My name is Sebastian Kabitzer. Yeah, I'm the CEO and founder of About GmbH, a startup from Munich. Before I start, I would like to thank you to the DFI organization for the invitation to present today. The title of the presentation is Breaking Down Data Silos to Enable Data Analytics to See the Big Picture on a Special Foundation Construction Site. Before I start, I need to admit, yeah, I studied civil engineering. I work as a construction manager on infrastructure construction sites, but I'm not that expert in the deep foundation industry. So if you have specific questions, don't blame me. I'm more the general construction manager. So yeah, my presentation is divided in 2 parts. The first part is the introduction and yeah, like the general experience I've made on construction sites. And the second part is really a specific use case we worked on and still work on with a special foundation construction company. So in the beginning, I would like to start, as always, when I heard presentation with a story. This is me back in 2012, as I said. Yeah, I started civil engineering and started as a construction manager on a big infrastructure construction site in southern Germany. Have you heard about Stuttgart 21? Maybe the chair. That was my beginnings, not the easiest construction site. Yeah, I started and we come to a point where we were behind the schedule, had an increase in costs and an unexpected bad performance. And we didn't really know why. So my colleagues and me was sent weeks before to a lean construction management course of my former employer. And then we heard about the multi-moment analysis. Maybe you heard about it in German, the Multimomentaufnahme. So on this construction site, then we, because of the problems, we invented and implemented the so-called Strichliste. It's not a joke. We hired some students. Are you students in the audience? Perfect. It's a really good paid job. So when a construction company asks to do that, it's perfect. We asked students, hired students on the construction site, and we counted and measured really everything. We counted, for example, the loading activities of the machines, the excavators. I mean, I need to say it was a huge mass flow construction site. So we have, yeah, huge earth or soil movement. So we count trucks on sites and the duration of stay. We measured or also count material input, output, the material on stock, idle times, and many things for a specific period. So yeah, the result was really we got a big picture. That means we were able to see external and internal process dependencies. We were able, of course, after we analyze it, the process flows on the construction site, and we also saw the bottlenecks. That was awesome. So the results or the reasons, yeah, we detected. Here are a few examples. First example, that the excavator was just too weak for the task it has to do. So there were idle times, the semi-trailers were queuing. It was also the other problem that after a rainy day, the semi-trailer did not really or had problems with the underground. So they reduced the velocity on the construction site. And also we had a problem with the material supply chain. We also built a trench with pipe. The material was not always on the right time on the construction site, so we had a delay from 1 to 2 days, and also that causes idle time of the machines. So here are just a few examples of what we did. It's really easy after you have the data, I mean the data of your Strichliste. We changed the excavator and changed a more strong one, so the performance was better, and we reduced the idle times of the trucks. For the bad velocity or bad performance of the semi-trailers, because it's underground, we also bring in some semi-tractor in the circulation of the logistic. And last example, we negotiated with the contractors and changed the contract to a consignment contract. So in the end, I mean, all these actions improve the process and thus the performance on site. But of course, this was a huge effort. I mean, as I said, students also cost a bit. And it was just only, how to say, a period snapshot. I mean, you do it once, and then you have that data, but you just did it once. You need to do that regularly if you want to have that information. So I asked myself, wouldn't it be great to see the big picture from all your job sites digitally, in your real time, from anywhere and anytime, and that's fully automated. And I thought, it's an awesome idea. So the only thing what I need is data. And here's the problem. What I experienced on the construction side, well, I was as a construction manager, either you don't have any data on your site, I mean in the execution phase. The execution phase, that's really important, not in the planning phase. So you don't have any data, or you don't have sufficient data. It's a huge effort, it's the third point, to generate the data. And the last point I experience is that data are often trapped in data silos. Maybe that's also the reason why 96% of construction data, I think, is a research study of McKinsey, were unused in 2018. That was, how to say, the idea or the challenge or the motivation to found About. So what we do at About, we built a technology platform, which where you can get access to technology. We simplify the access to technology and services. All the data we bundle and we visualize. And the last point is that we, of course, with all the data, we do data analytics. And the image on the right side describes it's really, really good what we do. We are already, as a startup, headquartered in Munich, as I said in the beginning, and we are in quarries because we're also in the mining industry and on sites in 10 countries in Europe. Okie doke. So that was part one, the more theoretical part, and now it's part two. Jump to part two, the specific use case. So the early beginning of last year, I had this phone call, and with a guy from a special foundation construction company, and before I had this phone call, I prepared, and I was sure that I will ask him these questions, what I said in the beginning. Wouldn't it be great to see the big picture from all your job sites digitally, near real time, from anywhere and anytime, and that's fully automated. So, but I didn't come really to this point. The guy on the other end of the line was this guy here. This is Markus Daubner, head of digitalization of Bauer Spezialtiefbau. And as I said, I come not to this question because, Markus Daubner said it would be great to start with digital capturing of manufacturing process for heavy drill rig directly from the machine, and that fully automated, without manual tasks, fully automated. And he said the data we have are, of course, machine data and telematics data. So again, I need to admit and say, I was not the expert and still not the expert in this deep foundation. So this is the process of a Kelly rig. You have the main process. It's drilling, it's welding, emptying, it's the inserting the reinforcement case, it's the concreting, it's pulling pipe after the concreting, and also you have that sub processes, for example, tool change or something. And between all these process events, there could be idle times, a standstill because of necessary works, of course, to do, for example, refueling, or repair works, or just waiting for the concrete truck. So when you just have sensor data, only sensor data, it's quite hard to detect specific processes. For example, such an, it's possible, but to detect it reliable, for example, the tool change, the reinforcement cage, or also concreting process, just with sensor data, it's, as I said, pretty hard to detect. And in my opinion, and that what we learned, it is impossible without just with sensor data to find out the reason for standstills on site or idle times. For example, as I said, it's necessary for refueling, the repair works, or also the concreting things. So in general, I need to say, this is more, as I said, the general perspective. Our customers, when we start to work with them, machine telematics data are the absolutely basic data, and it's perfect, it's needed. But again, when you want to see specific process, really want to get that big picture and do that deep dive into your process, then it's necessary to add source data, really to get the information about external internal dependencies. As I said, not just with sensor data, it's quite hard. With sensor data, you would have in specific processes the information gaps. And the most important thing with sensor data, you don't get the why when you have the bottlenecks. Really, the reason why a process on site is not really good. So my opinion is, what I learned the last 4 years, you can't eliminate bottlenecks if you don't know really the reason. So the big question is, what did we do with Bauer or with the Kelly rig to fully automate it? The task to recognize the process. We add a new data source, and we taught the Kelly rig machine to see and to understand the process environment fully automatically. That means, we give the machines eyes. We installed these devices, and this device is hardware device you can purchase on our marketplace, in our About marketplace. So it's an intelligent plug and play hardware. It's an edge computer where you can also plug in a camera. That is what we did at the Kelly rig machine. Again, it's plug and play. You can install it less than 15 minutes. It's no canvas needed. It's, again, really just plug and play. And the bad thing is you can really install it on every machine. A drill rig, we install it in Switzerland on big mining dumpers, excavators. And here are some technical information. I don't want to make a deep dive to that technical information, but the most important ones are the edge computer, which is in the device, plus the sensor. So what we did is, with this device, or with this, technology, we are able to generate image data from the machine when it's necessary. So it means not that we generate data every 10 seconds or 15 seconds. Every time when something specific happens, for example, the swiveling or the machine stands more than 5 minutes, we can generate an image and of course do the analysis with the sensor data plus the image data. So we at About have this two, how to say, or the backend is two lines, the SDP and the IDP. The SDP stands for sensor data pipeline and the IDP for image data pipeline. And we are able to process this different kind of data and fuse this data after a specific time to really get the process. And what we did is the first step with the use case with Bauer Spezialtiefbau, we classified sensor data. That was the first step. For example, when the Kelly drill rig was swiveling or moving to the right, we classified the movements with the sensor data. And because of the movement of sensor data, as I said, we get images. Then we started to classify them to train the image recognition algorithm to detect specific objects in the images. The third step was then the fusion. So we fused sensor data with image data, and in the end, you had that higher level, how to say, recognition of the process steps. Okie doke. Here are a few examples of how the image classifier or the image algorithm work and detect things fully automatically. As I said, for example, this pouring pipe, quite hard for a sensor to detect that process. And these are image algorithms which detect that process in the images. For example, also the drilling. We have here the swiveling or drilling and swiveling then to empty the rig. That is also important because you see the soil of or the color of the soil. So you could also train algorithms, for example, to detect specific soil classes. Maybe we didn't do that, but could be maybe possible. And the last thing is here example of a reinforcement cage and setting of a reinforcement cage. So to dive in a bit deeper in that, this is how the artificial intelligence, the image classifier really detects some examples, really detect the things during construction activities. This is the first example, as you can see here, the Kelly drill rig just do the work and the swiveling. You can see the rectangles. This is an example of inserting a reinforcement cage. I hope this is the correct term. So as you can see here, again, the image classifier detects also the borehole, for example. And of course, we have to each image also the geo position. One moment. And the last example is inserting a reinforcement cage. It's an external, how to say, an external process not from the Kelly rig. As you can see here, it's inserting the reinforcement cage and also the concreting process afterwards. So all these are, of course, process information. And this process information are delivered to the backend of our system. And additionally to the process information, the KPIs directly are transferred to software as a service dashboard, where you really can then analyze and see the process fully automated. In this, I don't want to explain that in detail, but you can really see the duration of process and things like that. And the most important thing, again, it's fully automated, no manual work to do. A little teaser. I'm not allowed to speak about that. With Bauer, we currently work on other algorithms and use cases, especially for finding the reasons for idle times or still stands. And as I said, I'm not allowed at the moment to talk about this, so that's the reason for it to be continued. Maybe next year we will see. Now, at the end, my conclusion. What data and data analytics, and this is a really good example of Bauer Spezialtiefbau, can do, or what you can reach. The first thing is what I said, the big picture you will get with data and data analytics. The second point is that with data and data analytics, you will be enabled, or how to say, you can make faster and better decision making on sites. The third point is, of course, you see, again, idle times and the reasons, so the efficiency and the productivity you can increase. And the last point, and this is really important, we save resources and reduces environmental impact, what we, in my opinion, desperately needed for our society to do that. And yeah, this is the end. Thank you for the attention. And if you have any questions.
When you reach that point where you said that you're not quite sure how to capture sort of the downtime, you're going to jump back to sort of an app that somebody had to do manually to see if you've done that through sort of image recognition was really enlightening. Thank you very much. Great. So, any questions for Sebastian in this presentation? Sorry.
Thanks for the presentation. Really, you also mentioned that the certain model that cannot and recognize more. Reinforcement that recognize more is doing the same, only as a different thing.
You mean here on the right? You can see the bowl. Yeah, it's. I mean, I need to say that the technology of image recognition and artificial intelligence is really, how to say, in a really the last year really developed. So what we always say to our customers, that what the human eye can recognize, you can also taught a machine. So when you have that image and you can really recognize that there is a borehole, then you can train it an algorithm or the machine. And yeah, the algorithms can detect after a specific amount of data. It depends. There are objects in the images which are pretty easy for the algorithms to detect. And there are, of course, objects which is more difficult for the algorithms, but it's always the data. If you have a huge data amount for a specific time, and we train the algorithms all the time, and there's then the point where you really get, or the algorithms recognize it. So it's all about the data. With huge data amounts, you get those things recognized automatically.
You're asking about recognizing the borehole or recognizing the specific borehole line
Okay, yeah. I mean, we just have the position from the machine, so we fuse the data. So of course you can then calculate which borehole it's. We have, I mean, the technical part, the edge device has, I think, around 12 or 13 sensors, units like gyroscope, things like that. And with the fusion of the GPS position, things like that, the recognition of that, you can fuse that and get, of course, also to each image the geolocalization or the geolocation.
During the presentation, you mentioned data silos, and a lot of data with silos back in 2018. This is very advanced, this is the new way forward. Is there a risk that as we develop data like this new kind of way of looking at it, it's going to sit in its own little silo that other people won't be able to read and look at?
I don't really understand this question again, sorry. I'm sorry.
I'm thinking that as we advance with the data collection, what you're collecting data here is more advanced than we've done before. Because it's advanced, will it sit in its own little silo by itself? You won't be able to access it. Others won't be able to see that data because it will be very localized to yourself, or how you analyze it, how you capture it.
Yeah, I mean, what I said in the beginning, we built a platform, all the technology we have on the platform, when you purchase, it's integrated. So of course, we have some, how to say, uploads possibilities to get the data from totally, how to say, maybe also silos. But we really have work on getting as much as, how to say, possible REST APIs, for example, to include the data. So we have that standardized REST APIs, but of course, for that cases, if you have the data silos, you definitely have the options that you can manually upload data, but we don't want it. We really want to give that automated, the more advanced than Sure. Yeah, we have really big companies from Switzerland and also from the UK in the mining industry. So the customer said to us, we want to have the events and all the information analyzed. We want to have it in our ERP system. So we really deliver already today information SAP. And there's another one, I don't know exactly the name, but we deliver it automatically. It's like a rule that we every second day or something, they get the data pushed into the ERP system. Because in the mining industry, they really want to see the production and also what internally then happened. And we already implemented that. Yeah. Really good point. We label all the images for specific customers at or in our company. So there are many tools to give the data outside. There is, maybe you heard about Amazon Turk. It's a service where you upload images and there are people, I think, I don't know where, then label your images, but we do it in Munich for ourselves because of course, data protection things. And we don't want that because these data are really valuable. We don't want that any kind of other firms will get the data and can start to train image like that. I really need to say, I'm not the CTO, but so unsupervised learning, I heard about it, but I can't really say it's supervised learning. I would say that.
Yeah, absolutely. Thank you. I was wondering, like, the example that you presented is primarily related to building construction, usually with right?
Yeah.
Like you mentioned, a few of the other applications of image correlation. I was wondering, have you used extensive devices for like damage detection or in this process, or defects and before pictures installed, or I know you mentioned it, like you could bring an excavation, identify this oil type. Can you explain a little bit more of this system down methods, or
Then what you mentioned are more the external data, which it's quite hard to get the data from a machine. So what I presented the last slide, in the end, so we work on that to really find the reason, and I'm not allowed, as I said, to talk about this. I mean, maybe another example, we also work for the German railway provider, Deutsche Bahn. It's famous. We have 2 big construction sites, and there we detect as soon as a truck or any other truck is entering the construction site. So we count. And we also analyze what he has loaded. For example, sand, soil, I don't know the English word, keys or some, I don't know, stones. So then we analyze, and the Deutsche Bahn gets the information about what of the mass flow is on the construction side, and have also the possibility to do a check for, when there is an invoice or something. And all the systems also used for claim management, quite interesting. So sometimes only just the image, because we have the image in the system. So our customers just use the image to have a better claim management possibility, I would say. Or just maybe Markus Daubner from the Bauer Spezialtiefbau, maybe answer them.
Any other closing comments before we move on to our next presentation?
Thank you.
Our final presentation before our break is with Mark Pennington from Digitalisation. Mark is the technical director of Digitalisation Engineering, and after 7 years in design consultancy, Mark has spent the last 23 years working with foundation contractors. Mark chairs the technical committee for the Federation of Planning. Mark did chair the technical committee for the Federation of Planning Specialists in the UK from 2011 to 2021, and has a particular interest in moving the digital development of industry forward. Mark leads the digital development within BT Engineering, and was integral in developing the UK Federation of Planning Specialists guide.
I thought I saw a hand up and want to make sure we get that question before we move on.
That's mine.
Never mind.
I'm not sure why. Shouldn't be there, but we'll do it in a second.
And we're going forwards and backwards.
Yeah, just.
Has this got a pointer?
It does have a pointer. This.
It's on the red one.
Yeah, it should be on.
Right, this one.
And
Okay.
in the impression this time, so we just have to manually.
Perfect. Okay, that's one. Good afternoon, everyone. As you just said, my name is Mark Pennington. I'm the technical director with Balfour Beatty Ground Engineering. And thank you very much, EFFC and DFI, for inviting me to talk this afternoon. I spoke on this subject 4 years ago in Rome. Then I entitled my presentation, BIM, a UK Foundation Subcontractors Perspective. So I want to move on a bit from that. I want to look at what's happened since 2018 to 2022 and see how we've developed and how we've moved forward. This presentation I've entitled Getting the Right Mindset for Data Management. And mindset's a word that I've heard quite a lot over the past few weeks and months, in fact. Not least at our company conference a few weeks ago, about Beatty's company conference, mindset was a key area. And I think, over the last 3 years, we know with the pandemic, people's mindsets have changed in the way they work and the way they analyse and look at digital data. So I think people's mindsets can change, and they can change very quickly if they want to. It's on with that, is it? Oh, I see, it's on with that one. That's it. Okay, so I'm going to discuss in four main areas this presentation. I'm going to start off with progress in 2018, look at how things have developed and how things have moved forward. I'm then going to cover a bit more on the importance of consistent data. I think getting data consistent, having consistent data is key to moving forward. AGS format is one way of doing that. Jason spoke about that at the beginning, a little bit of how we're trying to develop AGS format. That's one area where we can, and I'll go into a little more detail around that and what we're doing on that in the UK. Before covering some blockers. There are some blockers to us developing digitally, but more importantly, some solutions. So I want to come up with some solutions and how we can get going forward with this. Okay, so to start off with, I want to look at what's in place to enable data capture. What was in place in 2018, how this moved forward. This is in the way of standards and in the way of technology. So standards, we've now got the ISO 19650 standard within the UK. That's replaced the 1192 suite of documents. And companies are now being audited against that to show their compliance with data management. It's quite a key document. So there's standards in place, people are audited against to see where they are. We've got the uniclass coding, so each element's got a specific code, so we can search and we can find data if it's coded in the right way and in the correct way. The CIC BIM protocol, that gives further guidance on level 2 compliance. And we've got the digital plan of works, which sets out it sets out a framework of responsibilities and how we can work collaboratively. So these are sort of key documents that are out there and standards we can work to. As far as technology goes, technology also has developed. Common data environments are commonplace. People are using them at various stages of projects. They're typical now for most projects going forward. Modeling software,
keeps improving, keeps getting better. Modeling software is in IFC format, so it's easily transferable between things, which is great. Cloud-based collaboration, cloud-based applications are continuing to improve. You can see some of the presentations we've had already from Matthias and Sebastian, where they're looking at capturing information and sharing information in cloud-based formats. So that's growing and continuing, which means it's easier to share. The 3D analysis tools that we have, share how we design products with how design foundation works, which shows how that can link in with models that we produce. Ground profiling, again, there's a lot of ground profiling tools and ways of looking at things, which as we understand more about the ground and we can look at the site investigation information in a clever way and model it, we can understand it better. Again, we can see the stuff earlier on where we can model the ground based on as an installed piling information, which gives us greater knowledge. So how we analyse that and how we use that only brings us benefits. And then we've got digital twins. I didn't know we were going as far as modelling the digital twin of the Earth, but I know we've got digital twins of projects going on. So basically, there's a lot in place around standards, around technology to allow digital transfer to work well and to be standardised. I think the key we've got to is raise awareness of these tools and these standards, so everyone's using them in the same way. And I know these tools, but I don't know them in depth. I wouldn't claim to know all parts of the ISO 9650 standards, but we've got to have people within our businesses and the way we're working that do understand these so that we follow standard rules and way of doing things. Moving on a little bit to guidance around how we use these tools. So it's around 6 years ago, I think maybe 6 or 7 years ago, within the FPS, we produced some guidance notes. And these guidance notes were around things like introduction to how we help industry, how we can help the industry if things are digitized. We have an introduction to use of data, both for ourselves and for our clients. We have definitions, we've got classifications, we've got use of software. So these are documents we put together and basically the help of our members within the Federation to understand and start using these BIM or data management in a better way. These have been taken on board and we've seen them floating around the industry a little bit and we've seen them getting a little bit, a little bit of interest brought around, but they haven't really been embedded in the way we work. I think they've been embedded for a couple of reasons. There's no contractual requirement for them to use them, and people's mindsets haven't really changed. That we need to use these kind of documents or these kind of guidance. So they're there, but they're not being used in a full way. I think these need to be updated. We do need to push these, and I think the key one of these is the one around classification, how we classify and how we transfer data. And as we move forward in this presentation, I'll explain what I mean a bit more about that. So we have the guides, we need to update them. How are these guides being used? And this is a slide I presented in 2018. And even in 2018, I said these guides have started to be used, and individually in pockets, there were some pockets of excellence around how they were being used. So the common storage areas, some people were using them better than others. So some projects were religiously using a common data environment and making sure people were updating information, loading information into common data environments, and that was the center of everything. You had to have your data stored in that location. Other projects weren't. Some projects have better ways of capturing data. We've seen the presentations earlier on. We're capturing some driven precast data in a very strong way. New ways of capturing data directly from the rig. These are pockets where there's excellence going on in the way we're capturing data, and also the way we're sharing data. So some people, we can capture data in the field directly onto an iPad, and it will be shared straight back to the design office instantaneously. And again, there are examples of projects where that's happened. And looking at the agenda for the conference, I think on Friday morning there are sessions where I'm sure we'll see some excellence going on in these areas. The same thing with modelling. Ground models are growing. We've got as-built information. The construction logistics, so we plan sites in a digital way is all growing. But again, I see this happening in pockets and better on some projects than others. So I would say it's not really been embedded within the industry, and it's not consistent through the industry. And I think there's three main reasons around that. It is not embedded properly. One is there's not consistency in the way we adopt things, the way we do things. People do things in different ways. So without a consistent approach, I don't think it will ever be adopted within the industry. The second point is around the contractual requirement. If there's no contractual requirement for us to receive data in a certain way or pass data off in a certain way, people will always think, why would they do it? Why would they go through the learning curve of learning a new way of doing something without any contractual benefit or any payment for it? And also, we're not seeing that the data and the models aren't always linked. So again, when I presented in 2018, I think it's worse than it is now. I think that's getting better. I think people were thinking BIM back in 2018 or previous was more around the modeling rather than the data. It's all really around the data and the models driven from the data. And so, I think we need to get the data right. It needs to be consistent. And as I say, the fourth thing I want to add to that, as I mentioned at the beginning, is around mindsets. We need to get people to change their mindsets that capturing data digitally is something that we have to do, is the way. So that's really the key around it. That people can't say, well, why should I be doing this? It should be a case of people really want to do it because they see the benefits. As we go to the blockers and solutions, there are some ways around that I can think of. So to explain that in a very simplistic term, let's try to explain the benefits of consistency and the benefits of having some standard inputs and standard outputs. I've got a very simplistic model here, where we've got So we might have a project data set and a project model for the main project that we're working on. We might have a foundation model, which is created separately to that for the foundation elements that maybe people in this room work on more rather than the overall big project. And we have some standard information. We have some information that's come out of the main project data set of a project model, which is fed into the foundation team and has given us an output. There are three areas here where we can drive consistency. One is the AGS format, the AGS farm. Jason spoke about it. I'll cover that in a little bit more detail going forward, but it's been around for a long time. We can generate that further and make it consistent. Within the Federation of Piling Specialists within the UK, we've developed an electronic pile schedule, which is a standard way of transferring design information through to contractors in a standard format. We find there's a lot of inconsistency in the way that information is transferred, which leads to a lot of problems and a lot of issues. And then Uniclass coding, we should adopt that. We should be using that more consistently. If we have all of our elements of our projects adopted in coded in the Uniclass way, we'll be able to search data a lot more easily, search particular elements. I think if we get the input data correctly, we can look at the way we model the data in the middle. So, as we've just had some presentations with both Sebastian and Matthias, where they're looking at the ways they're analysing that data as foundation contractors, how we're getting that better information. We've had standard input tools into how we're analysing that data. It will make that process a lot easier, whether we're taking it directly from the rigs, whether we're inputting it to iPads, how we're modelling it in the detailed foundation design teams. It will be in a standard way. We can then sort the output from those tools also in a standard way to feed back into the project model. So it would be consistent throughout the industry and it will make the flow of information a lot better. That flow of data would then drive the development of the model. So the data will drive the model. So the foundation model which has been developed will improve and develop because the data will flow. And then, as we said before, a key behind that is then getting some contract in there. There should be contractual requirements to pass the data into the foundation subcontracting environment in a standard way, and a standard way to pass it back out. Without that contractual requirement there will always be some kickback, I believe, some kind of some resistance or some challenges. So, taking that a little bit further then, and looking at how that works and the benefits of that through the whole project life cycle. I think we can all understand that information, as we get information, it improves, or we get more information through the project life cycle. And this little graph here shows information increasing as we go from desk study through ground investigation, through design, through into construction. And the level of information that we get continually increases. We can extend that on further really to as-built information or into asset management, and then the level of information is even more. But we do know that as we pass from one stage to another stage, there's always a learning curve. We drop back in the level of information we have. We move backwards sometimes if the data isn't transferred properly. So from desk study through to ground investigation, people picking up the SI may go backwards in their knowledge. And all that does is cost time, cost money, increases risk. So if we can get a good data flow running smoothly through the project. So again, this consistent data that we're talking about running through the project at all stages, we will remove that, the inefficiencies around the data transfer at the different stages. That will improve the way we communicate geotechnical risk. It will save time. It will improve accuracy, I think, and overall, it will have an impact of reducing boots on the ground, the people that we need to look at this, to look at the project life cycle. So as I say, it will just generate some standardisation there. I think from a contractor's point of view, I deal with contracting. I look at the rigs out on site, they're physically putting the piles in the ground or the foundations in the ground. You've got to look at the real-time collaboration there we have out on sites, I think, with the design office and into the sites. I think that the data transfer we have at the minute is a lot better within the design office, within the planning stage in the design office environment than it is down at the construction phase. I mean, perhaps the presentation we've just seen in capturing data at construction stage, I think we agreed there back in 2018, there was a lack of information, or there was siloed information. The way to get that from the site is to have simplistic information or simplistic apps and tools to be able to capture that. If you've got the very clever information of capturing from the imagery we've seen on the previous presentation, if that can be fed into a standard application so the guys on site can actually use it and have that information, they will be able to take the information from the design office, look at it in a simplistic way, input the construction information in that standard format to be able to feed it back. So getting standardised tools that are talking standard language is key. And again, with the Balfour Beatty, we are developing standard applications now, as other companies are. But I think the key around that is getting the consistency in the language that we're using in using those applications, or else, you move from one company to another and you're using it in a different way and capturing it inconsistently. So moving on to how can we capture data in a standard way? The AGS format is a format which has been around a long time in site investigation perspective. For 20 odd years, we've captured site investigation information, putting into the standard AGS format. And that proves very beneficial, particularly on the larger projects. We are capturing a large amount of site investigation information. You've got a standard way of capturing this site investigation data. You can analyse in a single way. You can get tools to analyse it, to give fence diagrams through boreholes, to understand the ground in a much better way. The view is to take that AGS data and to make it more applicable to all foundation elements. So, and that has been developed, that has been taken forward. Here we can see this is a schema which is put together of the AGS format. We can see we've got design information at the top here, we've got construction information in here, we've got testing information, and we've got information from supply chain to capture all information around foundation elements. And behind each of these little elements here, there's a lot of data that's captured. And the data that's captured is aligned to the UK standard, the piling specification of embedded retaining walls, which means we're capturing the information we would always capture on site or capture from the design office to hand to the sites. So the data that's held there is no different, but it's in a digital format in a standard way. So then programs can be written to extract that information and present it in whatever format we want. So as we said, that's in a trial stage in the UK at the moment. The beta version has been developed, it's sort of out and being trialled. On HS2, HS2 have agreed that that's a very good project to try and trial and get this running through in a standard way. Problem with HS2, it's a very large project. There are 7 different construction sections going on. Most of the different construction sections are being led by joint ventures, and these are joint ventures both at construction phase and at design phase. So you've got a lot of people involved to try and make this work and to try and get this trial working on. The benefit of HS2 is they did have the foresight on RSP2 to do a lot of preliminary test piling well ahead of the construction works. So that was viewed a very good area to trial and to give some testing to this AGS format, the preliminary test piles. If we could turn the preliminary test pile data on all of these 7 different contracts, HS2, into an AGS format, it would give it a real good test. The problem, as I said, we've had is that we've got a lot of different people involved. So this is an example here from, it's actually from two of the contracts, the M1 and M2 contracts that I've been involved with. And here we can see, you know, we've got HS2 involved, we've got a principal contractor involved, which is a joint venture. We've got a design JV involved, which is a joint venture, and we've got a piling subcontracting organisation, which is a joint venture. All of which have got to buy into this trial and develop and learn this new way of working or trial AGS for no real benefit, because it's not contractually required on HS2. It's just something that if we did it, it would give us benefits. And we can see there's a DJV, they've got an element to do. They've done that without a problem. They've worked together and got the AGS format going. The blocker at the minute is around the foundation team and capturing the data on site. Again, because the two different partners, the two different piling subcontractors working on that particular job are doing things in different ways. And they're struggling to agree a consistent way of capturing this information to then turn it into the AGS format, because they've all got their own way of doing things, if that makes sense. We're getting the pile testing information, and then, yeah, so then it gets handed back up into the DJV for compliance checking, adding into the overall project model before it gets handed back up into the client. So as I say, the AGS format is a standard way. It is one possible way of really standardizing the data. And at the end of the day, you would have one file which contains all the foundation information on. But it is, as I say, it is hard work in trying to get everyone buying in and changing people's processes to make it work. Okay, so moving on to, this is, so back in 2018, when I presented this stuff, I thought there were a number of blockers, a number of issues that were, that were getting in the way. Some of those are the same, some of those are different now. I think I picked out what I think are some of the 5 main areas that we have issues with in getting standardized digital data working properly on foundation construction sites. One is, by definition, foundations are typically the front end of the projects. So we find that projects aren't set up, they aren't running smoothly in the way they are by the end of the project, or by the superstructure or whatever else is being put on top of the foundations. So there, I think there really needs to be a digital mobilisation as well as a project mobilisation. So we're all mobilised to get onto site, but we mobilise and get onto site and start building things before we've actually got the project set up properly digitally. I think when we start building and start getting going, then the follow-on stuff that comes after the foundations, I find is a lot more advanced, because there's more time to get the digital processes embedded within the project processes. Does that make sense? So I think having a digital mobilisation and reference to digital mobilisation at the front end of projects would be the solution. 2 of them are around shouting around what we do, and conferences like this, I think, are areas around where we're seeing excellence and where we're seeing good things going forward. So we have to educate clients, and we have to justify the cost of learning curves, I think. Both of those things are big blockers. So clients, why would they want digital data? They can build things at the moment. There's no benefit really to them in getting things digitally. They see the foundations are essential, but they're not maintainable. They're all hidden in the ground. They're not really interested in them, just want them done. They've got to see the benefits of having digital data. And I think the only way we can do this is by showing them where we've had success. So again, the presentations we'll see today, and I think on Friday morning, I think will be integral into shouting about why digital development is the way forward. And also to develop our own companies, our own businesses, into investing in improving learning curves and changing the way they're doing things, because it will cost money to improve the way we do things and to develop new ways. I think the big question, I think Jason put it up at the front end around liability or ownership of data. It's always a challenge when things are flying around and there's very little barriers behind stopping data transfer. That's the key to, people get nervous about that, because people see what other people are doing without checks in place. We've got to try and knock those barriers down, because that's, my view is, where we do get that and we do get good data flow on projects, it only improves the project outcomes, because people on the project are better informed. So again, I think that's got to be around clients' own. The client has to own the data. It shouldn't sit within the contracting organisations or the design organisations. It needs to sit with the contractor. And good data management does leave a commercial advantage. You can see that. we've got the next instalment of what's happening within Bauer. We can't see it because it's commercially advantageous for them to develop that, if that makes sense. But that's which is good. People do need to have commercial advantage from developing things. But I think to get digital data transparent properly, we've got to try and break some of those barriers down. We've got to make it more open. And if we have more standardization, I think it will reduce that kind of closed doorness of, I'm going to develop something better than you. There may be a utopia to get to. And so finally, just to summarise, really, this was the summary I put up in 2018, and I think the summary is exactly the same. And I think the summary is exactly the same as we are now. I said in 2018 that digital development will change the foundation industry in the next 5 years. I don't think it has. I think we're on a journey still. I still think we're moving forward, but I still think we're still talking about some of the same things, in all honesty. And hopefully we can get to a stage with discussion later on, and with events like this where we can start to really start to move forward. I think we have moved forward. I don't think we stood still, but I think we can move forward more quickly. One thing that the pandemic has led to a number of things. I think within Balfour Beatty, I've had a quote that 250 people were using Teams on the 15th of March 2020. By the 25th of March 2020, there are 25,000 people using Teams very regularly. So people can change when they have to. Teams is a very simple thing to use, and everyone uses it now, and it's commonplace. But it wasn't, pre-pandemic. People weren't using it. A lot of the digital tools we use are as simple to use as Teams. In honesty, you can use them if you set them up in the right way. We need to change the behaviours of the workforce to implement, as gets around the mindset. So that was 2018. I didn't mention mindset then, but mindset's my key word at the moment. I think the tools and the structures in place, in fact, that's improved. Consistency and the common foundation language needs to be developed. We need to use that, that's my view. And we need to get some contractual requirements in place to be able to enforce this properly. Thank you very much.
Excellent. Thanks very much indeed, Mark, and thanks very much for leaving us with some very poignant food for thought. And I think your first point, I think you're absolutely right that digitalisation will change the foundation industry. I think that the rate of change is always slower than we think, but I think that there is real danger for those that don't get ahead of the digital transition will be left behind. And again, I think these excellent examples in the presentation today are really well put in terms of digital transition. So we should all be taking that too rapidly, I think. Okay, any questions for Mark then? Presentation?
A couple really, I think. One is, what do you think will drive that sort of digital change? It's been sort of 4 years and we've not seen it push on as much as you'd expect. What's going to make clients demand more of it, push for more?
Well, I think it's only around the case studies, around where they're seeing it being, where clients can see the benefit of it, and we can demonstrate the benefit because it's saved time and cost to other clients. If that makes sense. So, one example, we use HS2 had the foresight to look at preliminary test piles very early on in the process. It wasn't quite early enough, but it was early on, so it could influence a lot of the construction, construction that was ongoing. And we've used that example to other clients. So HS2 are clever enough to use preliminary test piles early on to give data which really impacted the way forward, the construction. I think we could say that, the same thing. If HS2 or large clients were adopting digital technology and insisting and contractually requiring it on their contracts because they could see the benefits, we could share that with other clients, if that makes sense, and other clients will buy into it. And I think it has to be through, it's the larger projects and the larger clients to see the benefit of it, it will then filter down. But I think it's only through, personally, I think it's through shouting about it, showing the benefits.
Well, certainly in the US, it's been about regulations that help the owners adopting specifications. Contractors enough already have to give us data, and it has to be data we can read, and it has to be data we don't use to pay a software vendor to be able to read 10 years years down the road, and it has to be documented so we know what we're getting. And then grudgingly, contractors in some cases are enthusiastic, in other cases that adopt.
That's almost the next step, isn't it? So you have rock clients that are specifying digital data. You know, what was the transition from potentially clients who weren't taking that piece?
I'd love to word that question because I would say the same way. We've had experiences in North America where the specifications by an owner have required a customer, in my case, a contractor, to implement some of these tools, and then they've seen the benefits. So on the next project, which has been smaller and not specified, they've asked for the same services, or they encourage their machine vendors and brick vendors to give them data because they've seen the light and changed their concept.
And on that question, well, it's my second question, which is, I think, around mindset. This is sort of collaboration. With digitalization, we always talk about collaboration, but we've got a very adversarial contractual environment at the moment. Do you see that changing realistically? Do you see clients willing to change their mindset? And contractors willing to change their mindset?
My view is around who owns the data. You know, people are worried, I think, and aren't willing to collaborate because they don't want to, immediately share the data. They don't want it to be open before they, before they have a chance to review it or do whatever they want to do with it. If that makes sense. So, is owning that data is the key behind that. And I don't know the answer to that, in all honesty, but I do know that the challenges around people having open formats or open ways of communicating, come from the commercial and the legal teams, the legal people involved, saying, well, actually, look, if we make that open and make that free, it will give us an issue, or it could potentially give us an issue contractually. So I think it's the ownership of the data and how people can't be contractually, I don't know, liable for passing the data on in real time.
Yeah, usually development changing how it's driven and the response was about regulation and requirement. I think that's only half of it. I think the other way to do it, I think has a more rapid response, is simply making people's lives easier. You can make someone's life easier, they'll adopt it. But you used the example of MS Teams. People just jumped on and started using it, but you don't know how to work it. Now, if they didn't do it, then they'd be sending emails and waiting for replies. So, we all use Uber apps and all these other, because it makes their lives easier and you can do it like that. So I think one of the areas is you can unlock making people's lives easier.
But it is getting over the learning curve of making it easier. Because even using an Uber app, well, people, 250 people were using Teams in 15th of March when it made their life easier to use it, but they didn't because they didn't have to. And also an Uber app, you have to learn how to use it in the first place, so people can't be bothered to learn how to use it until they actually need it. And then when they've used it once, use it again. So it's getting over that first initial learning curve of doing it. I think is the challenge.
Unfortunately, more on the first because it's digital in the next 5 years. I'm wondering, there are out there a lot of traditional civil engineering curriculum, and the way we teach our students, maybe at the moment, I know they need around the future transition. Some of this is whether you think might be a good idea to for associations or for companies to reach out to universities and let it know, transition to the new era.
Yes, well, I think it would be beneficial to reach out to universities or to anyone. I mean, obviously universities would be able to add a lot of knowledge and a lot of direction in that. Again, it's trying to get companies, contracting organisations or consulting or organisations to actually think, right, what's the benefit of reaching out to universities? That's going to create some costs. They've got to see something out of the back of that cost of doing that to get the benefit. And that's the challenge, I think. So it has to be demonstrated that by, paying for that, or going to the academic organisation will get you some benefits. And I think that's the challenge. I think it's a good idea, but it's a case of making that step of right. Why and how.
Yeah. Nothing purely digital way, so you're not just learning how to code, but integrating that part of the engineering, what also you're using digital skills and applying it to solve engineering challenges, teaching and learning through and not planning through. So I think there are some positive steps to there's more you could do. So if I could touch on all the questions before I go, then I think we that's looking for a great time. So if you're not taking a 14 minutes or the second jump to next one, you can meet back in a half. Thank you.
Good afternoon, my name is Diederik Bouwens. I'm working for Fugro. I will give you a presentation about the digital transformation, machine learning and ground modeling from Jim to the BIM. The content of the presentation is of two parts. First, I will start with an example of a current project I'm working on in the Netherlands on the highway A9 near Amsterdam. And part two is about the perspective of digitalization in foundation engineering in the Netherlands. I will try to picture the situation at the moment in the Netherlands and the expectations I see in the near future. Now, first of all, the project of the A9, the highway, you can see that it is in the south, at the south of Amsterdam. The highway is here, A9. It's around 10 kilometers long. And what Fugro did was do the soil investigation, so collect all the data, but also do the design of the works. So we designed the embankment, which is widened, so stability and settlement calculations. We did retaining walls, civil structures, so piling design, noise barriers, also piles, hydrology, we looked at that as well, groundwater tables and so on, monitoring and the temporary works of that work. As you can see, it is a typical Dutch area. It's very flat, with fields, very much peat and the soft soils, typical for the Netherlands. And it is near Amsterdam, Schiphol Airport. So we realized that we had to do a lot of site investigation from the start of the project, and the contractor, which is a Spanish contractor, was really pushing hard to finish everything as soon as possible. So we had to really hurry up to collect around 2,000 CPT data and around 120 boreholes, which we had to do. So we had to work in an efficient way, and we also wanted to have one point of single truth. So no discussions about the right file or the wrong file or which one is reviewed or whatsoever. We wanted to have access for everybody, so the client, the government, and us, 24/7. And we also wanted to reduce waiting time and also reduce all the emails sending around. So what we did, we found a solution in GIS connected to SharePoint, which we call Gaia Books. And all the data was handled through that portal. Now here you can see how it is looking like. So here you have the A9 again, from here to here, 2,000 of CPTs and 120 boreholes. The locations are there. When you zoom in, it looks like this. All the data points are there. And when you click on one of those data points, you get into SharePoint, Then finally you can see the CPT. So it's nice to look at the CPT, of course. You see here in the beginning a sand layer, but then from -4 until -12, there's a lot of soft soils, clay and peat. It's really a difficult area. You can also see that we are underneath sea level with the surface. So the whole project is underneath the surface level of the sea. Now, when we collected all the data, then we said, okay, now we have to do the interpretation and the classification. So we have to look at the CPT data and define the layering, what kind of layer, where does the layer start. And since this is a lot of work, we again were pushed by the contractor to do it as quickly as possible. So what we decided to do is reduce time by using machine learning. So train the computer to classify and interpret soil data. And we also wanted to have ambiguous interpretation, so not like one geotechnical engineer is classifying a layer as peat and the other one says it's soft clay. And then you get discussions. You don't want to have that. And also for the geotechnical engineers, when you have to interpret the 2000 CPTs, it's quite boring by hand. So we wanted to have less repetitive work for the engineers. Now, how did we do that? We have a lot of experience in Amsterdam. This senior staff over there, they know the soil really good. So with 5 of the people, we were sitting down and looked at around 40 CPTs at the beginning to make a proper classification and a proper interpretation of the data of the 40 CPTs. And we use, of course, the experience, we use lab testing, and we just we're discussing in detail, okay, which layer is this? We call it old sea clay. Yes, that's correct. Another one said, no, it's hydromia clay. We had really discussions in the beginning, but finally everything was clear, and the 40 CPTs were done. Then one engineer continued and did another 360 CPTs. So in total, we had 400 CPTs fully classified and interpreted. And that was our training data set for the computer. So we said to the computer, okay, this is a CPT with cone resistance, with friction. And this is the layer which is connecting to the right depth. This is your example. Now take another CPT and make your interpretation yourself. And the computer starts to learn and starts to improve itself. So here you can see, there's an example. In the beginning, the computer said, okay, this is my interpretation. But we said, no, you should also discover all sea clay. And then later on, the computer came up with an extra layer because he's learning himself. Another example is given here, and that is the end situation that we said now is it almost ready to start using. Then the errors were so small that you only had to adjust a little bit of layering, and the work was not so much anymore. So then in the end, we had, in a real short time, we had the interpretation of all the data, and it was all corrected and checked. From the data and the interpretation, we started to build a 3D underground model, so a ground information model. How did we do that? We used, in this case, Leapfrog, that is software from the mining industry. Developments in the software are going really, really quickly. So maybe next time you take another piece of software because someone is buying the software or developing something else very smart. So it's depending on the developments, but this time we said Leapfrog is the best for us. And we combined all the data from the CPTs. This was the input. We put it in the model of Leapfrog. And then Leapfrog can build himself a fully 3D ground information model. And of course, there's interpretation between the CPTs, but the distance between the CPTs, because we had so many, was really small, like 22 meters or so. And you can also see that the top layer, for example, here is gray, and that is the embankment of the A9, that is sand. And you get also a gap here. And you say, hey, the highway has a gap. No, this is of course a civil structure, which is not modeled by us, but is concrete. Now, in the end, we were able to combine our ground information model with the building information model from the client. So you got the total model of the whole area of the A9 in one model. And that was the first time we did that, and it is really creating additional benefit. Now, when we had the 3D ground model ready, we said, okay, now we start with the design. And also the design work was pushed by the contractor, and we had to hurry up. So we said, okay, we want to have the 3D model as a basis, and we take from the 3D model, we take longitudinal sections, cross sections to start our calculations. And that is easily done. In a few minutes, you get a longitudinal section of the whole project with all the CPTs in it. You get also cross sections from the 3D model, and you get this kind of pictures. And then we said, okay, we take the 2D cross section, we take it as a starter for the geometry of our calculations. So we changed, where we took over the cross section, for example here, and we used that to make a input file for our calculations. For example, for settlements, stabilities, that kind of stuff. We didn't need to do that anymore by drawing or programming. No, it was taking out of the 3D model into a 2D cross section into the calculation. And then we said, okay, now we have to run many calculations because design is changed or phasing is changed. So you need to do a lot of redo work. So we said, okay, we will automate our calculation. So for all those cross sections, we made software with Python to make the calculations in one run, and to get also a proper revision management, because that's of course always the trouble. You make a calculation, then someone else makes the calculation again, and in the end sometimes people get lost. What is the reason why we did that extra calculation? What is the last version? What has changed? Nobody knows. But now we get a proper revision of that work, and of course it's more efficient, and you avoid to make mistakes. Now, how does that look like? Here you have an example. I hope this is working now, because that's always the truth. Yeah, we build up the geometry automatically. Then we put on the surcharge, that is the gray layer, and we start to do settlement calculations. And you can see that the surface here is settling. So this was all automatically done. And also, this is an example of one cross section, but we could do that for many cross sections. So that is shown here. And you can easily make, for in this case 37 cross sections, the calculations in one row. So this saves a lot of time, and again it also saves problems with revisions and so on. Now I want to go to the next slide. Yes. So that was the example. So we made it possible with 5 steps of dealing with a lot of data using our Gaia books. We did use of machine learning to make the classification and interpretation of the data. After that, we built a 3D ground information model. And from that model, which was believed and is a full model, because we had so much such a high density of data. From that model, we could easily make cross sections, and those cross sections were used as input for automated calculations. Now, yeah, that is, according to us at the moment, digitization in geotechnical engineering. I talked about settlements and so on, but we can also do this for piles, of course. But then you more look at GIS plates, and then, for example, where you have all the CPTs, you can also easily calculate pile tip levels and so on. So that's a little bit different, but same principle. Now then, part two, the perspective of the digitalization in foundation engineering in the Netherlands, according to me. I don't know everything, but I did my best. So what I see is that the government, contractors, engineering firms, everybody is busy with a kind of digitalization. And why do we do that? Because nowadays in the Netherlands you have more and more contracts where you also have to do the asset management. So during the life cycle, you collect so many data that you have to deal with, that you have to do something about automatization, because otherwise it's impractical, too much work for people, and it costs too much money. Besides that, those kind of big projects, cost control is very important. So you start to make automatization to get cost control based on the actual data. Also to bring efficiency, and at last to make impact analysis. Like I said, we find out in the Netherlands now with an A9 project that design is changing quite a lot of times during the design process. So you have to adjust all the time, and you want to do that in the most efficient way, but also know what the impact is for cost, for time, for phasing, and so on. So digitalization, it appears in many forms and combinations, but in general we talk about BIM, parametric design, digital twins, project information management, and that is all established in all kinds of software. It's like, it's not chaos, but it is widespread, so to say. And everybody is busy, and I think the biggest steps are made on a big project. So when a new project starts, you take all the information with you from the last time, then you do something different in a better way, and you make improvements. That's what I see. Now, and then I will try to say what is the government doing, what is the contractor doing, and what are the engineering firms doing. Now, at the moment, when you look at our government, they were late, according to us, a bit slow, but Deltares, which is an engineering firm related to the government, they're now taking the lead with developing GeoLib. And Deltares is always the company that is delivering the standard geotechnical software, but it is outdated, and now they, together with the engineering firms, and there's also money from them, they start to develop a new, fresh tool called GeoLib, with settlement calculations, piles, stabilities, all the sheet pile walls, everything is there, but under a standard umbrella, which is completely new, and there's a lot of automation in there. There's also creation of underground models, so that is really good, but slow. It's coming, but slow. TNO, that is, how do you say that? Investigation company, so to say. They own a lot of Dutch data from the soil and from the underground, and they make now also 3D underground models for the total of the Netherlands. They are not so accurate, but there's still a lot of data, and you can for free access that and use it as a first impression of the area. So that's also a nice development. And I also mentioned the universities. I think they are good in adjusting their program for the students, because the students that now start to work, they can, most of the time, they can program in Python, so they can make Python scripts. And that is, of course, needed to make the digitalization possible. And the geotechnical engineer still needs to know how he can program, how he can make software. And that's really beneficial. And it's a bit like in the old days when I started with Excel and Visual Basic, and now it is replaced by Python. So that's from the government. From the contractors, they are in general taking or trying to get control over the total project information management. So that's GIS, that is SharePoint, that is Relatics, that is BIM, everything together, and they try to be the spider in the web. So to connect all the separate software and all the separate tools, because they know there's it's not possible to have one tool for everything. No, it's needed to connect the tools to one center, and then based on the actual data you have control. That's what I do. But they also did a really nice thing. They created a platform, the digital engineering community, and that platform, most of the Dutch big contractors are there. There's also a software company and also engineering firms like Fugro are now joining, and they are a platform, and they are especially focusing on BIM and parametric design. And the goal is to optimize and manage the design. They work together, they share information, really important. It's like a market. You have the meetings, people have ideas, people have money, or people have knowledge, or people are interested to buy the final product, and they go in a separate work group starting to develop a piece of software. Some parties say, I'm not interested, just go ahead. When it's finished, they show it, and if you're still interested or you get interested then you can still buy it. And so it's in an open discussion, and really a lot of new ideas are developed over. For example, when you have an embankment, you get settlements, you get settlement plates to measure the settlements, and the interpretation of that settlement data, you can use that for prediction of the final settlement. Now, such a tool is made within this platform. So that's really nice. And sharing information, that's, I think, very important and also a difficult one. Then the engineering firms, maybe I'm a bit I criticize a bit too much, but what I see, the engineering firms are a bit afraid to share information, so they stay in their own company, and they are starting all kinds of initiatives. So some engineering firms have a little group of Python experts, which create software. Some engineering firms are working together with ICT companies. One firm bought a ICT company, so they really work together. But in the end, everybody is inventing the same thing, and it costs a lot of money. So I'm not that proud on it, I have to say. Yeah, could be better. Now, and then I also try to picture the near future, and then I'm from infrastructure. So I look at the high-rise building industry. I think they are ahead of the infrastructure people, because, for example, they have already standardized the BIM. They have already libraries. They have rules how to call objects in a building, and that's in the infrastructure world not that far. They also start to look at the big data and the artificial intelligence. And they are also ahead of us with asset management, so the life cycle information management, because a lot of things will be measured to find, for example, the right moment for maintenance. But how to deal with such an amount of data, that is completely new to the sector, I have to say. Now, example, what I heard from the building sector is that they use artificial intelligence. So they ask a computer to decide what kind of materials do you use in a house to meet the amount of environmental impact of the building on the area where you are building. So the computer is saying, hey, you want to use this isolation material, but better to use this one because otherwise you won't get a permit. That's what already is happening in the building sector. I think we also will get into that in the infrastructure as well. Here's another example with a permit. So you have buildings, and automatically, for example, fire and safety for fire is checked by the model. And also it is checked with the area where you're building, and in the end the computer says, okay, you're getting your permit, and no human people is anymore involved in it. So that's going to happen, or is already happening. Now, and then the last topic, the asset management during the life cycle, that will be a very important one. I already experienced with our government that we said, hey, you can measure bridges or tunnels every month and share the data with you, and then you can see, depending on the informations, when you need to do maintenance. But they said, no, we don't like to have the data, because then we are the owner of the data, we have to manage it, and maybe after 7 years there's other software, and we have to come up with a solution for that, so that will cost us money. And so they're really afraid of the data, and I think in the near future then people will start looking at that, because yeah, we have to deal with this. Now this is an example of a tunnel. All tunnels in the Netherlands from the 60s, we measure them now to at least have a feeling about the behavior of it, because building a completely new tunnel is of course very expensive, so better find out what is happening and do maintenance. But then you need to know, you need to measure. This is my final slide. So when you talk about the opportunities and limitations in the digitalization, I think in the Netherlands the knowledge and the tools are there. Everybody is enthusiastic and they want to go along with it. When you look at the limitations, we need from European or Netherlands itself standardization. So everybody is talking the same language, using the same libraries. But when you look at the geotechnics, we are always dealing with soil. So it's not like you have a standard and you use always the same standard for every project, because the soil is differing and also the project is different. It's totally different when you are talking about 10 kilometers of highway instead of a building pit of 60 by 80 meters in the middle of the city. So you need to adjust, and I think we need to be aware of that, that you cannot standardize everything. That's impossible. Thank you.
Thank you very much indeed. I thought there were some excellent examples in your presentation of how sort of collaboration at a larger scale can really benefit digitalisation. What the initiatives you showed from the Dutch government, really helpful, and it's something at a national level to provide a ground that can use. And that, I love the contractor collaboration. I think that's great to create an open marketplace which encourages innovation, encourages new ideas, and some great thinking. So really positive. Thank you. Perhaps it's time for a couple of quick questions.
Are you ready to comment that your information groups work with building distance?
Yeah, you mean the gap between the CPTs? So the software we use, it makes an interpretation between the CPTs, but it's using all the CPTs around it. But it is still an interpretation. That's true. Yeah.
level here, and here, and maybe here, and your kriging may give you this. Yeah. But this level can also be here or here. Yeah. And if you have a galvanization curve like this, and here it looks like this. Yeah, because you know it. And then it would be maybe possible to say I want to have at least 90%, then I have to use this one instead of this. Yeah. Do you implement it?
No, no. And so in this case, we said we have 10 meters in between. You have seconds, for example, stability. Then this difference is not so big. Okay. So effectively, finally,
I calculate usually pipes.
Yeah, so when you look at the valves, then you also look at the geometry. If the valves are in this project, I'm thinking about it's not so exciting because the minus C sand layer we always find is sand. It's not different that much. So the top layer is the layer of heat, that is the exciting one. But then for
but you don't have cooling yet to.
It is in the leapfrog software. It is. Yeah.
Yes. You can say at least 5% and then.
Yeah, you can play around it. Yeah.
And you need to define which layer is better, goes down, and if it's a worse layer, it goes up.
Yeah, in this project we didn't do that. But normally, yeah, of course. Okay. No.
Thanks.
So I think we're just a little bit limited on time. So if Andrew has a comment on that, you wanted to pick up. All right.
No, it's just me telling you that's what they can.
Okay, fantastic. Thank you. So 2 questions at the back.
Thank you very much for the very interesting presentation. You are basically doing the same as Arcadis, and I share what you said at the end, that engineering companies don't share their knowledge. But actually, I'm interested in your first example. Was it something with the leapfrog model and let's say overall geotechnical build approach that you were coming up with, or was it something your client suggested?
No, we came up. It was in our offer. And so when we won the project, or when we made our proposal to the contractor, we put it in. Because I was interested, because I'm a technical guy, you know. So I thought this must be possible. We didn't do it yet, but I thought this must be possible, and I also saw the benefit. Because it was such a big project, and so of course you have to invest hours, time, software to make this. But I thought it will pay us back, you know, and it will be more efficient, and that is what the client wants. So that's why we put it in the proposal. Then we got it, and then we said, oh, okay, now we need to start. Yeah, but we didn't do, we only did a ground information model below surface, and the client is working with structural engineers on the model above. So that's the one you can also see in the beginning. How fast do we go back? Now we looked only at geotechnical engineering. So this was built by the structural engineer, and we only work with loads. So we need to know loads from the piles or loads from the foundation, and then we work on our own models. Yeah.
We had to take the loads from the as well.
Now, in the example I gave, that was the embankment. So then you build it with sand. So you know already the geometry in the final phase, and you also know the requirements about settlements, allowances, and then based on that you start to do those kind of calculations. Yeah.
innovation or the AI project, the second step is machine learning. Did you create any intellectual property?
No.
No,
and I was also surprised. We had two teams working on it to get the best result. One team in Germany, they used Robertson and Campanella, the theory which is always used for soil interpretation, and one team in the Netherlands which said, we don't look at any theory, we just look at data. It was an ICT girl. And it really surprised me that the team in the Netherlands, only based on ICT, had to just train the computer as good as possible. They got the best result. So Germany, in this case, lost.
Okay.
Our final presentation, I'd like to introduce Jamie Wilson. Jamie is a senior principal geologist and data manager with Geotechnical Construction in Ontario, Canada. He has 25 years experience in applications of geospatial technology to civil engineering works, with a speciality in foundation projects. His past work includes the development of the information management systems for the Wolf Creek Dam and the Boom Dam, and he's currently the chairperson of the DFI's Project Information Management Systems Working Group Committee. Jamie,
Great.
Thank you very much.
Thank you. Yes, so I am wearing two hats today. I'm visiting you as a consultant from Canada, but more so as the current chairperson of the Project Information Management Systems Committee. I do. Oh, okay. Yeah. You sure can use this one? I can. Yeah. So some of you will notice that I've crossed off the words project and systems from the Project Information Management Systems Committee name, and that's because we're currently debating a name change, and the intent is to leave the very narrow project role and expand to the entire systems information management where we can. And certainly come talk to me if you're interested in more about what this committee is and what this committee does. But the focus today, before I go into a case study, is the very first, in front of an audience anyway, rollout of our new data management guide specification. Very excited about this. I'm sure you are too. There are hard copies of this available at the DFI booth as well. So I'm going to be focusing mostly on these specs, given this new role. I'll tell you the history of them, a little introduction, and then a very brief case study. The Netherlands owes me like 7 minutes here, so we'll go fast. A lot of this comes from our work in the United States, and in my case in Canada, with the U.S. Army Corps of Engineers, who has really been the early adopter from about 15 years ago of information management applied to foundation projects, mostly around dams and related large infrastructure projects. So a lot of the work that went into the DFI guide spec was in some way based on or in collaboration with the U.S. Army Corps of Engineers. And I say that in part because one of our goals is to expand this far beyond the reach of one U.S. federal government agency and have it be much more globally applied. So in 2018, USACE, U.S. Army Corps of Engineers, took their individual specifications from these various projects and combined them into their guide specifications. So one thing that's not project specific that can be shared amongst the organizations and outside of it for projects that want to use good information management. And one of our roles in this DFI committee was to provide consulting to the Army Corps and help them make their specs. But at the same time, and after that, we were branching out and making a modified version of their specs and the guidance we provided to them to make this generic version that is not specific to the US and not specific to the federal government and is specific or intended for DFI use abroad. In 2021, the Army Corps published their generic guide spec, and we published ours in shortly after, and we're working on a few different versions of it. This is how many pages? 30 pages long. We're working on like a 6-page version for grouting and grout curtains that very quickly gets at just the basics of good information management for much smaller projects.
So for those of you on the Zoom, I'm waving around this document, but here's how it looks and where you can get it. This is the DFI.org committees, project information management systems, and then you can download it directly. There's no paywall here. This is meant for universal use. And don't look at the details too quickly here or too much, but the basic idea is to go through anything you would find in an information management spec outside of the foundation world. So rules for documentation and metadata, rules for creating a schema, rules for making it geospatial, which we do a lot of in the foundations world. And there are subsections for various specific subject matter expertise. So the types of data we expect to get for each of these items, and each of these sections may turn into their own standalone documents as well. So again, the goal of this is to start with something that has been developed with taxpayer money in the US and take out the specific stuff. We've also tried to soften the requirements that we don't feel that we need in DFI, for example, security. The US federal documents are full of very limiting rules to keep out terrorists and to really protect their infrastructure. We don't necessarily feel that we need quite that level of security to protect the data in a borehole log, for example. And the intent of this is that owners of any kind and any size can take this and cut out the parts they don't want, or just cut out the parts they do and make a much smaller version that's specific to their project and at the scale and the size of their project. So you don't need 30 pages of schema if you're just making a little drill shaft or something like that. But the goals are similar to, I'll steal the word mindset, to words we've heard earlier today. We're trying to make sure we have quality, we can talk about what that means, digital data collected in an efficient way, allow the owner to access the data during construction, ideally in real time or near real time as appropriate. And I don't think we've talked about this much today. The owner should have an archive of the data after construction, something that they can actually read without maintaining a software license for a company that may go bankrupt in 2 years and they won't be able to access the data. So, industry standard data formats and that kind of thing. And view the data in a common geospatial context. So everything in a map and a model if it has some location in 3D. Now, don't read this in detail, but we've had a lot of discussion, a lot of changes recently on the subject of data ownership, because we're dealing with two different mindsets. One more time. We have the owner who says we're paying for construction. We need all the data, full stop. If you're collecting in our project, we need it. And we as I guess, citizens of the world or its digital twin would like the data available for use as well. But of course, contractors and vendors want to protect their proprietary information and their business secrets. So we're trying to meet halfway. We've consulted with some legal professionals. But I guess the bottom line here, literally in the bottom, is that the owner needs at least the data that they're paying for that is specific to what a contractor is constructing. If the contractor needs to cut out proprietary information or remove some columns from a table that does not actually affect the owner's ability to own the project, then the specs will compromise on that point. Rather than have this issue delay the data flow forever. And of course, again, the owner can modify this text as needed. So the specs require a few basic items. We need a centralized, ideally enterprise, ideally relational database, or if you prefer just a database, accessible to the owner with all the tables of data, and whether that's in AGS or DIGS or some other format or something built for this project, that's for the contractor to decide. And at least in North America, we're pretty GIS focused. But for the purposes of this conversation and the specs where you see GIS, you can substitute BIM, because the type of concepts we're talking about are not limited by any differences between GIS and BIM. We can discuss after those differences and similarities. But the point is data in a digital twin, data in a geospatial model that has some three-dimensional thing. And now let's talk about foundations. A lot of these specs it came out of the barrier wall world. So secant pile walls, diaphragm walls, where verticality and overlap is really the key. And the specs call for reports of each element or each secondary element. So basically, if you build something, you generate a report that describes it, and that report becomes part of the database, part of the IMS. progress drawings and as-built drawings of construction are detailed in the specification as well. And we're starting to see government agencies and owners, at least in North America, ask for dashboards. And the specs currently do not specify this, although the owner is welcome to say, give me a dashboard to access all these items. That's sort of the secondary part. So a brief case study. I'm very sensitive of time here, but I'm also sensitive that this has been a very Bauer-heavy day, and I guess we're in Germany, and that makes sense. But this is another Bauer project. In this case, it's Bauer Foundations in the U.S., although there are many other contractors involved. The Herbert Hoover Dike cutoff wall around Lake Okeechobee in Florida. This is Lake Okeechobee. Florida is the state in the southeast. There's tremendous concerns of seawater infiltration and overland flooding. And the original dike built around this lake almost 100 years ago is pretty useless. So they're very slowly, you can see these different areas, building cutoff walls and jet grout curtains to reduce the seepage in mostly the overburden. And my firm has a scope to handle the data and meet the specifications that look a lot like the ones I'm waving around so that the owners can get this data in real time. Briefly, there's construction that requires some pre-drilling, and in this case, it's a cutter soil mixing because Bauer is involved. Basically, rectangular panels of slurry that overlap to create a continuous seepage barrier. The challenge with verticality, as I've mentioned, is that if you are installing very deep elements and one deviates a little bit up station and one deviates a little bit down station, when you get down to 50 meters or more, there may be areas of insufficient overlap. So a lot of the data we collect in 3 dimensions and put in this database and visualize in the GIS is focused on proving the quality of the wall from a continuity perspective so that there aren't gaps. But there's other data collected as well, geology, of course, quality control data, pre and post installation, field data, et cetera. It all goes into the database. It's all visualized in the GIS. It's all covered by the specifications. Nothing really magical here. We've got a database, enterprise database, central database, whatever language you like. We have tools to put things into the database and tools to get things out of the database and visualize it in the GIS. But this is all one continuous documented system. No silos, no parts that aren't eventually put into a database and documented per the specifications. You've all seen databases before, so I won't show you much here, except that one of the challenges we have, at least with government agencies, is direct connections via ODBC or other technologies that have to go across a firewall and view data. So sometimes we get around that by putting data on a website in interactive tables, but we find that, and you'll nod along joyfully as I say this, we get a lot of, well, can I just have it in Excel? Can I have it in Access? Can I have it in something that I'm used to? So the good specification and a good information management system will use whatever is the best technology on the back end, but still have the ability to deliver the data to what people are comfortable with. And if that is several different things, an ASCII file, an XML, we saw great examples of this, and a Microsoft Access file that is updated every few hours and can just be downloaded and used by someone on the other side of a firewall, so be it. I have 2 more minutes, so Christian, great, thank you. So here's the good stuff. So the GIS, you've seen interactive maps before, I'm sure. Everything in the database that has a geospatial location can be visualized in 2 and 3 dimensions on a website. And you'll see there's little numbers here and little lines that represent the overlap at multiple depths. And that is the most important aspect here, and what is ultimately looked at by the owner before they click on these things and get the hyperlinks as you're seeing now. So we have data collected from a drill rig. It's immediately uploaded via an FTP site into the enterprise database, geoprocessed into 3-dimensional geospatial elements, visible in the GIS and exported to these various PDFs. I went through that very quickly because we're out of time, but do let me know if you want to see some of this in more detail. Anything geospatially in a planimetric view can also be shown in a profile view. So we have the exact same technology in profile, the same overlaps, but here shown at their respective depths or respective elevations in the context of geology. The point of having everything in one place is always context. Show me something in the context of something else. Quality control data in the context of the geology in which it was collected. And 3D as well, this is just an excerpt of a much larger web-based three-dimensional tool, but here you see this is the secant pile portion of the wall with overlaps every few centimeters, although it's taken from every few millimeters. That's just a little overkill. What you really want is a dashboard that tells you the exact elevation and the exact location where the verticality is insufficient. You don't need to see every single depth cut, but it's there in 3D should it be needed. Drawings and reports look like this. These are the same types of overlaps that you saw in the GIS, but this is something that can ultimately be printed and put in a filing cabinet, which some owners feel is still necessary. To me, having this accessible through a hyperlink in the database is acceptable. But here you have 3 different elevations at an overlap on either side of a secondary element. So this is the real digital twin that the owner will archive for a diaphragm wall. Here's the same thing, but this is really page 2. You can see the continuous trace, in this case from a hydromill. It could be from any other drill methodology that measures verticality either during excavation or with an ultrasonic device or something after excavation for the slurry hardens. Different methods that will give you the same result, which is how vertical is my element? Does it sufficiently overlap? And, skipping ahead, thanks again for everyone sticking to their time. An as-built drawing, this is something continuously produced in GIS and exported to CAD, although it could be produced in CAD and exported to GIS if you prefer. But the point is, at the end of a given section of wall, in this case 500 feet, we have one continuous, they call it a profile, although it's not a profile, one continuous section with the overlaps at the 3 different depth cuts that the specs require. And this is another final work product that is archived by the owner and used for eventual acceptance of the project. And here's an example of one of these dashboards that at least the federal government is getting used to in the US, really a one-stop place to access all the various geospatial, tabular, drawing, PDF tools, as one would expect from a dashboard. And I'll skip a few of these other items and just leave you here with a few questions. We're trying to get a better understanding of if there are specifications at all and to what extent they're similar in other countries. And please find me to discuss that if you have examples. And can we, at least in DFI or in conjunction with EFFC, get better use out of the work we've done in these specs and let those of you who don't have something similar get decent use out of it. So we'd love to see even a paragraph or 2 of this have utility elsewhere. Sorry, I almost got it in time, in the reduced time, but I appreciate the invitation and being able to represent North America and DFI here for you.
Thanks very much, panel. Thank you for 5 very enlightening and very inspiring presentations. Really useful discussions from the audience. I think we'd now like to sort of perhaps just pose you 1 or 2 questions just to get sort of your thoughts on perhaps some of the wider challenges and perhaps more importantly some of the solutions that we should be looking at from an engineering perspective. And then again, I'd like to sort of open up the opportunity to our audience as well to pose questions to you as a panel. But perhaps if I could just sort of start off with a nice sort of broad opener for you though. What do you sort of consider as the most important action we should be taking as ground engineering professionals to promote digitalisation in our industry? So you tap in order, so someone's always going to have to do this on first. Okay, Jamie, we'll start with you. We'll figure things out.
I'm not proud of this answer, but from my experience, the answer is mandating. At least at the entry level, until a contractor or a vendor who has very small margins and very little time and resources to spend on that until they're told that they have to by an owner, we may never reach some of it. Now, of course, we want to live in a world where innovation and where companies can see the value and try things, but in many cases they just can't afford it. And same thing with jurisdictions and owners of small projects. They may not have the resources to innovate and to test and to onboard new things. So mandating them through specifications, through regulations, will force the innovation and force the uptake of digitalization, and that will have momentum to carry on.
I think you mentioned mandating there. I mean, again, how could we do that in a fair way that doesn't disadvantage small, medium-sized enterprises? I'm not trying to give you a plug for your standard specs.
That's something that I struggle with myself, and that's very fair. I guess we're hopeful that the mandating the specifications is general and simple enough that existing, ideally open technologies or widely available technologies or very affordable software can do at least these scales of a project. I think for a multi-million euro, multi-million dollar project, a few $1,000s required on data management is reasonable. For a much smaller project, and the scale of the specifications and the scale of what you're asking for data-wise needs to be much smaller to match.
Yeah, thank you. Someone else the same question.
I can agree on that, but also, as the gentleman said over there, that to try to solve a problem that, that's for the small business as well, that they can really see that they benefit from using the digitalization. And that's what we have done with our system, focusing on the process and helping them in that process with digitalization tools. That sort of also brings it up and makes it so, I would say.
Solving that problem.
Yeah, and then you can work your way up from there.
Yeah. Thank you. Mark, same question to you. The most important action we should be taking?
I think he's talking positively. I think he's talking positively about things that we've done with the successes that we've had from developing digitally. Some of the things we've heard today, I'm going to hear over the next couple of days, those kind of elements we need to keep shouting about to make sure that others know people are doing success in pockets, and then the clients will know it, and we're pretty successful, positivity brings positivity. So I think talking positively about the successes we've had digitally, honestly, is a big indication. I don't disagree with projection requirements as well. I think that was all, but I think these things, there's positivity around it.
Thank you. Sebastian, your thoughts on the important action?
First point is, was already mentioned, give simple access to technologies to also data generation. I mean, the experience I made is that we make it difficult and also very high barriers. I mean, in a construction site is to manage several access to software. It makes a huge effort. And the second point is also to take away the fear and concerns of workers. Construction is also a big thing. With my experience, that of course data and software support is good, but sometimes you notice that there is as I said, concerns and fear, but you control the workers, and that also concerns you need to take
Yeah, and from your sort of, perhaps your experiences as a sort of a construction manager and sort of the experiences you've seen from where your systems have been implemented, have you seen sort of positive steps where you have been able to win over and convince construction workers that the machines aren't going to take over their jobs?
It's always true to talk and to explain what we need to explain and not attract the workers. And of course, I need to admit that also I am hard because what I said discussion after the presentation, we really needed to implement it object detector which recognizes people in the image and blurs the people in the image. And we need to show them that this system is able to do that. So that's also when the workers are walking in front of the machine, there is a camera. They will not be detected by the boss what this is doing. We also have sometimes you use that also images like presentation examples that the manager will go to the workers and explain. That would not again check.
And finally,
I think that was the next step. Major standardization. So, for example, the dashboard you showed, you might say that is something we don't have yet. And then they will put money in on a regular basis. They're not expecting what the future of the ICT system is. And then they can really start using it. Then you get proper estimate. I mean, the assets are most of the time owned by the government. So, I think that's one of the lessons that this.
Great, thank you. Any thoughts on that from the audience? Again, from what you've sort of seen and heard today, any particular actions that are springing to your minds in terms of what we should be trying to do as an industry to promote digitalization further? Maurice.
Yes, I think what I think here in the discussion is there should be a benefit. There should be a benefit for the industry. If you don't find any benefit, there will be no investment. And I think the benefit of all this information we gather, structure, we give availability to, we should gain in reliability. And so in design, we have to couple the installation factors, model factors, safety factors, whatever, to the reliable data that we get. If we even send it there, then the industry will follow. I think this is a major thing. The second comment that I have is we have to move. I don't have to be too much because otherwise you have part of my lecture on Friday. So. It's just for it's marketing. The thing is, we have to build more transfer. We live in culture in business. We have to hide. We don't want people to know that we make mistakes or errors or failures. And this, in connection with contracting, is a real issue. So we have to invest in transfers. All profession, contractors, engineers, have to invest in more transfers. We have to accept that failure is part of the deal. We shouldn't be punished too hard with levels. And that's, again, another slide. Where it's, I think.
Follow up on that, if I may, your earlier comment on there needs to be a benefit matches what we're hearing from the panel that you know, we need to be able to see some value. And I'll share one quick story. When I first started doing this 13 to 15 years ago or so, the only in that I was able to sell, for lack of a better term, to contractors so that they could see the benefit of doing all this was on the CAD side. That just being able to say, never mind everything else, but if you have a database that's geospatially enabled, we can automate the as-built drawings every night rather than having you have to pay your CAD person to do that for you nightly and let the CAD people do what they want to do, which is interesting design work, not by rote as-built drawings. So just being able to see that there's a quantifiable money savings that you can put into a weekly unit was what was needed to show the benefits, so that they would at least be open to looking at the benefits of all the other parts of the technology.
I agree. I think it's a small part of it. The big part of it is, and I was just there coming from sustainability here in Dark. We need to use is like getting more data, getting more soil investigation data, more product data. And doing so, we can optimize the time, gain into footprint, and that's the whole thing.
Your point on the benefits leads me beautifully to my next question. And I think, Mark, you were talking as well about speaking positively. So my next question is going to be for each of our panel members, what do you see as being the greatest benefit that digitalisation will bring damage in the light industry? So the greatest benefit that we see from digitalisation. I know we've had some suggestions in the discussion already, but Dietrich, shall we start with you?
First of all, it's great to do this. New way of doing engineering stuff. And then, of course, it saves you time. What I explained is that when the design is brilliant, when you are facing all the time changing during the design work, there are still change matrices which are finished, and suddenly a decision is made, and they want to do another design, and then they ask you, well, okay, sorry, it's some extra work to do with layer, that one won't shift. And then the decision is new. So, yeah, I think
Thank you, Sebastian. Your thoughts?
Yeah, first of all, I would say compensation. And I mean, we know in the construction is that we have a national productivity. Digitalization really can increase. And the second point is, for me, really important is transparency and also trust. Trust. Yeah. I mean, when you notice when I was in the construction manager, what we had a dispute with the owner because of some claim or something. When you have to read the data and there's no discussion anymore, I heard years ago amount of euros spent for like claim management that was huge. It's really good. Yeah. So first point, yeah, as I said, productivity and the chance to really increase efficiency. As I said, trust, transparency, and always disputes in the construction. Doing construction.
Okay, thanks. That's you. Okay, next to you, Mark, again, trying not to sort of, other than those points you've heard already, other benefits is, so I'm just trying to prepare you, Jamie, by the time it gets to you, it's
is reducing the risk, reducing the geotechnical risk. We've got definitions around it's a risk of insurance, it's not reduced, it's very everything we've got today, the assumption is about understanding the ground better, that we do construction or driving cars where we model the ground in real time and understand why it's broken at certain levels, or whether it's modeling the ground better with the GIS information. Or understanding it. So if we can get the data to understand the ground better, it's going to reduce the risk. Well, reducing the risk, but reducing the risk before the contractors, or whoever's taking the risk, managed to pass it down. Contractors again, with regards to holding the risk, it's reducing their risk. So it is generating and showing those benefits. And I don't agree, but show the benefits. I think it goes to case studies. The other small points on that, I think we have to take in small steps to maintain the transparency, which we spoke about in the break. If you have a big step and you suddenly move from people being able to see what they're doing and writing on the paper or typing it in, so it magically going into a black box and then spitting something out magically at the end. They're not going to believe it. They can say, well, how did we get there? So you've got to take it in small steps so people understand the process that it's going through. But then it's going to switch out. And then we'll get you to get to the stage to do that, but being able to run somebody in the front end, then the machines do all the work, call the data, spitting something out at the end. But I think we're reasonably distance away from it.
Thank you.
Well, I would say one big thing is collaboration, and especially now in the COVID times as well. Collaboration is something we emphasize on. Also that the companies that start digitalizing, they can, instead of having like we've had at least in Sweden in the contract on the contractor side, they have like Excel spreadsheets all
because getting the data in, and data can become information, which can become knowledge. So the company themselves can also sort of create a knowledge base in the company when they start utilizing and structuring the data.
Yeah, possibly restating that a great benefit is the holistic approach to the site, by putting everything, all your data into one place that you can really understand. I would say you can't understand everything that's happening on a site without all the different types of data. And it's not enough to just look at the geology if you want to understand why a pile has failed, because of course there'll be so many other attributes to solving that problem. And you can leave them all in one common context. Doesn't necessarily need to be geospatial, it needs to be relational database or something, but being able to compare different, disparate, separate types of data in one place will let you really answer those questions.
Right, thank you. And I think just again, taking from the point that Lars made around the interaction between digital technologies and sustainability, I think we've heard about the efficiencies that digitalization brings to the construction process. That's not just though about making things quicker or using slightly less materials. I think by combining our combined knowledge of what we know about the ground and our technologies, I think the example that Deep provided in terms of how the Dutch government are combining existing ground investigation information to create ground models that can be shared more widely is an excellent opportunity to reduce the amount of time and money that we spend on ground investigation, to be a little bit more focused, drawing on that information we already have. So I think digitalization in the right way can lead to some really fantastic takes that will help us from a sustainability point of view to really make our construction much more leaner and much more efficient process. Thank you. Any thoughts from the audience or comments? Sorry,
Possibly, I would say activity to people. We work we are doing a fantastic project, superstructures. We need people to really process. For digital transformation, there's not really the number of and digital transformation will be really a benefit if we create a more modern sector to attract future employees, students to enter into engineering. It will keep our existing employees in our sector also. And it's essential that that's a real way to better our jobs. And challenge I see here is that we are talking about very high profile projects because that's not the what about the base business? That is indeed a large part of our sector of what we do. I think we don't want to have two speed or two level type of project, but we need also to think about more standard project, more standard company.
Thank you. There was a question.
I had a question, but it goes along with the data. So in case you're still asking one person, I do have a question.
Okay, all right. So, Chris.
I think when I add that what the digitalization can enable us to do is to design and construct ever more complex structures that build and predict outcomes from that, but also with the possibility of being kind of removed a bit from the real world if the digitalization is not understood or misused. You could grossly be wrong in your prediction about that.
We have a question on the yes.
I'm wondering whether by extending those databases, it can be also results from numerical simulation, because there are those results stored in properties, policies, and can be used as benchmark solutions in the future, for nearby projects which are similar to this, for example. And
yeah, I think First of all, yes, I think on many projects we do include simulations. We wouldn't call that data, of course, but in the database for comparison. But what you're actually describing is what I see as one of the next steps, which is expanding these information management systems so that they cover multiple projects and entire regions rather than just one project at a time. So we can look at, and I think some of my colleagues here are doing that, but looking at the CPT results across an entire country rather than just one region or one project is a great role model for the rest of us. And for all the projects we do in a given state, for example, in the US, we tend to try to combine those and then eventually get some statistically significant comment on the efficiency of a certain drill rig and a certain type of geology, for example, based on the data from all these projects. That goes beyond including numerical simulations, of course, but your point about all these simulations being available in different regions is the right next step.
And also say that you can get from data, tools and data algorithms, basically in data. That's like a new technique that is, and this is the formula for networks, creating the data and all that. You know, you train your model to also analytical techniques and a combination of both data and theory to get like more accurate predictions.
We're looking at that. Second information, the sharing system project is really fast. This is really difficult to call. Now that client pay for it fast, promotes the calibration for a more easy calibration because we're going to report to the calculations. So, the chance that you have the same client, probably the calculation, and then working with another company, it's a difficult one. Should we really do that?
I think we have to evolve in this. We evolve ways to live. We were used to own the car, then we share a car. People share a house. We don't need to evolve into more again transparency in the way we share all that. I'm convinced we have to. It's only a question of time and maturity of the way people look at projects and that. It's a nonsense to keep these data for just this part of the project that everyone wants, whereas it could be used to the benefit of a new one in the various cycle. Or I think it's maturity process.
Yeah. Changing mindset of the users now as well.
It is, and I think it's important. I think in the UK, my experience, you don't use that information, particularly things like monitoring information. I think there's a lot of detail around the design. I think build structure you monitor against and you review it against your design. I think there's a particular boost that's it. It's done. We're not following up the step. We're actually saying, well, what, yeah, I did agree. What are the monitoring results out of the outdoors information? Feeding that back into the front of the model to learn. That's how it goes on. Irrespective of the modeling information you've got to the data, that monitoring is coming back to the process. It may be easier if there is a standardization process, but the output information is the standard format, and you get the monitoring information in the standard format. It may be easier to pick back in. So we're going to look pretty fast. I spend millions on a monitoring regime, sharing information and relevance.
Maybe an example of that using our system on several sites, and the honest, just one customer came up with this idea to really use the site of the best performance as a benchmark and try to compare to others and try to convince but also try to get the same standard, the same performance, the best construction, right? And also they ask how it's possible to use the data to make a better calculation. Performance calculation of the machine. And it's not really a deep foundation. The foundation is example. That's one example. To really try to put the data, as I said, to use Jerry, we would like to use the price to really make data optimize the operation.
And then we compare different companies now and at the same time.
Yeah, I mean, the contract.
That's what we get autonomous way, any business model and so on. So do this.
Let's just put down one company would try now to provide that.
Perhaps if we have one more final question from the room. So, Anna, can we have your data question?
Yeah, all my questions.
I'm sorry.
Because ultimately, you're right. It needs to translate design and developing the design of the benefit of construction. And I think the best example of the like how things have evolved out of proprietary things is through displacement files and the tools used for that. Otherwise, we wouldn't have just found the tools and all the data on proprietary to one company, right, or contractor. And so no one else has that data. So that kind of inhibits the further design or optimization of that particular system. What do we have to do to convince the contractor to, of course, have that competitive mindset to enable that data sharing that feeds back into a large database of all proprietary. Does it have to be a mandate? And it's the who has to mandate it? Because I wouldn't want this to be a mandate on my project. And I mean, Jimmy, you can speak from a U.S. perspective. Well, it's like so competitive, I don't want to do that. Come from the contractor's perspective, we get there. Here's my question.
Where like then contractors are more and more protected. Data we use really benefits to influence.
But the contractors need to provide data today, don't they? They need to, like piling contract, they need to provide the daily piling report or something like that. They do it in PDF format today, but they can do it in another format. It's just another way of providing the same data. But are you thinking about something else, or I mean?
No, I mean, like, I could see that, okay, so everywhere. Maybe people are more willing to share their tests from everywhere. So not like national. But that wouldn't be the same with like performance of buildings, measurements during drill displacement, stress distributions around the country. Like those more specialized data that feed into design. Like this.
Of course. Yeah, and then you need lawyers or attorneys to determine what is truly project data and what is truly business performance data. But to be clear, when I say that mandating is necessary to get this happening, I'm not necessarily saying we need to mandate that all businesses give up all of their business data, just the data needed to do the quality assurance on a project. Not very straightforward to determine what that is all the time. But I agree with you. You know, if it's soil data associated with the CPT, both the CPT results and the soil log results are truly data, not business intelligence, and could therefore be shared without making a company compromise on their business strategy.
Yeah, I suppose sometimes it might have to be built into the specification, because at the moment there's a certain amount of data that's got to be transferred across the spoken about under the specification. And that data should be free and open. So, you know, time taken to build, possibly time taken to build all the revolutions or the talk, maybe not. I don't know. So, and there are some things that contractors want to hold on their knowledge around speed production, for example.
that may not influence at the time. So how quickly they can install, how quickly they can build is a commercial advantage. But what they're going to hand over at the end of the day and what's going to be left in the ground. And yeah, not. So I think it may be modifications to specifications to get the right data to provide. And then the thing is then handed over, it's client zone, that client zone to me, we should work out how to get the transparency and the openness of that data. So it's not. If actually the DFI side look at the specification, I think it's great things. Two things I think it's great. One is only 30 pages long, which sounds really good to me. If you contain the right level of information, so get documents like that, putting information that within that, brought in as part of project specifications, so we have to provide that.
I think the commercial sensibility can be overplayed. In the UK, the people that work at piling contractors move around piling contractors all the time. So they're at one company 1 year, 3 years later, they're working at another company, and they take the knowledge with them. But you look at other industries like schools, for instance, the performance of the schools or public knowledge. They get ranked, and so people can choose which good performing school or less performing school. So I think some maturity reform. I think the trend is that there's more and more data sharing. We're going to be less precious about sort of holding on to data, because the collective sharing of it will outweigh the benefits from commercially holding on to a little bit of data, because everyone will have a massive amount of data, they'll have a little bit of data, and we can just.
I think the example you gave of that open platform of contractors sort of identifying problems, sharing data, and then agreeing sort of commercial routes to bring that to market for the benefit of others, and creating the financial model out of it is a really good example. And again, and thoughts perhaps in some of the challenges we've thought around the positives of actually sharing data in a proactive way and the financial.
Yeah. It's difficult, right? You can't find everybody's skills. There's a company COVID, nobody covered this. Right, to share for you. I'm talking about simple general foundation design or something like that. Everybody has its own Excel sheets, and now we make a proper piece of software. Like that, it's you account.
Yeah.
Share. Only they are right to share it with
I think there are similar issues in Australasia as well, where publicly owned ground investigation information is shared for wider use. I did like your specific example where you said that if people didn't sort of join a collaboration, then they could always join the later stage, or that they could find a software. So yeah, if you're not involved in the early stages and you don't have the problems.
Yeah, so interestingly, the fear that I hear from contractors and the resistance to sharing their data is not always on the business side, or not always on the intellectual property, but on the data quality side. Like, for example, the following, the specifications for a barrier wall might say that every, I'll use US measurements, every 30 feet, you need to show that you have no sufficient overlap. But the specifications also say you have to send your raw file that shows the verticality of the pipe. And what I hear from the contractor says, wait a minute, if we give them the raw data, then they're going to calculate the overlap at 29.5 feet instead of 30 feet. And what if we don't have good overlap a little bit above? No, we're only going to give them exactly the data every 30 feet. And the answer to that is the owner does not have the time and resources to do these calculations. That's why they've asked you for all these drawings and reports. And if the owner could say, either publicly in the specifications or privately in the contract or something, that we are asking you for the raw data, but we promise you we will only do quality assurance on the exact depth or elevations that we say so in the specs, then will you relax and give us the data that we need for our archive? So a little bit of transparency the owner side to put the contractor at ease that they won't be held to liability for something buried in the raw data that's not anywhere else in the specifications. The easier it will be on the contractor to overcome that.
I totally agree with that. And this was also where I meant by transparency and way more traditional laws. I believe the procedure validating the situation as well. In this case, we care that identity.
Okay, well, thank you very much. I think that's been a fantastic discussion. I think we'd like to just draw things to a close now for the discussion. We just want to spend the last few minutes trying to gain some of your thoughts by doing a live poll if we can get the technology to work. Kieran, are there any comments online as well? No. Okay, fantastic.
Sure, but the video is the audience.
But yeah, so if we have to show our panel a round of applause, please. Thank you. Okay, well, good afternoon, everyone. And on behalf of the Deep Foundation Institute and the European Federation of Foundation Contractors, I'd like to extend a very warm welcome to you all to our conference on deep foundations and ground improvement, with a particular focus on smart construction for the future here in Berlin. And what better way to address the smart construction for the future by having a digitalization workshop. So thank you very much indeed for coming along to today's session. And from a personal perspective, I'm